have paved the way for the progress that we are making today. And it is our responsibility to continue this legacy for our future generations. This seminar is an opportunity for us to come together, exchange ideas, share our knowledge, expertise, and collectively work towards advancing in the field of biotechnology. Firstly, I would like to request our respected Honorable Chairman Sir, Dr. Lokhan Chandra Seth Delit, Founder and Chairman, iCare Huldia, to kindly come up on stage. I would request our students to guide Sir. Now, I would like to invite Professor Shubroto Mondal Sir, Principal and Professor, HIT Huldia. Next, I would kindly invite Professor Krishnananda Chattopadhyay Sir, Chief Scientist and HOD, Indian Institute of Chemical Biology, Kolkata. Next, I would like to invite Professor Nitin Chattopadhyay Sir, President, Indian Photobiology Society, Professor, Department of Chemistry, Jadavpur University, Kolkata. Up next, I would like to invite Mr. Anupam Ash Sir, Senior Quantity Control Manager, Indian Oil Corporation, Haldia. Next, I would like to invite Professor Atin Kumar Mondal Sir, Professor, Division of Molecular Medicine, Bose Institute, Kolkata. Next, I would like to invite Professor Bhashwati Pandit Ma'am, Associate Professor, National Institute of Biomedical Genomics, Kalyani. And finally, I would like to invite Professor Shubhrama Gupta Ma'am, Head and Professor, Department of Biotechnology, in Secretary. Now, I would like to begin with our felicitation ceremony. First, I would like to ask Shalini Chaudhary from second year, Department of Biotechnology, to felicitate our respected Honorable Chairman Sir with a token of respect. Keeping up with the present times, as we try to be kinder to Mother Earth and promote a sustainable future, we are felicitating our honorable dignitaries with a potted plant as we believe in promoting a greener society. Now, I would like to ask Dorothy Ghosh from second year, Department of Biotechnology, to felicitate our Honorable Principal Sir. Next, I would like to ask Shomashri Dev from third year, Department of Biotechnology, to felicitate our Honorable Professor Krishnananda Chattopadhyay sir. Next, I would like to ask Shuparna Banerjee from third year, Department of Biotechnology, to felicitate our Honorable Professor Nitin Chattopadhyay sir. I would like to ask Dorothy Ghosh, Department of Biotechnology, to felicitate our Honorable Mr. Anupam Ash sir. Now I would like to ask Ananya Ghoshal, second year, Department of Biotechnology, to felicitate our Honorable Professor Atin Kumar Mondal sir. Next, I would like to ask Shomashri Dev, third year, Department of Biotechnology, to felicitate our Honorable Professor Bhashwati Pandit ma'am. Now, I would like to ask Shishti Lota Jana from second year, Department of Biotechnology, to felicitate our Honorable Professor Shubhrama Gupta ma'am. With that, we come to the end of the felicitation. The beautiful flute accompaniment in the background is played by Tista Chakraborty, a student of second year, Department of Biotechnology. Now, I would request everyone to stand up for the national anthem.
अरे बच्चा ना
पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंग विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
It is with great honor and reverence that we have assembled here today to light the holy lamp, a symbol of light, purity, and wisdom. This lamp represents the divine light that illuminates our heart and minds and guides us on the path of righteousness and wisdom. Now I would request our dignitaries and esteemed chairman sir to light the holy lamp.
দেখা যাচ্ছে না
Now, we have an inaugural song performed by the second, third, and fourth year students of Department of Biotechnology.
एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि तनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि
चतुराय दान प्राणाय दानमये दानोत्सुकाय दानमत्ताय दानोत्सुकमनसे गुरुपूजिताय गुरुदेवताय गुरुभक्ताय गुरुविक्रमाय गुरुपराय गुरवे गुरुगुरुते गुरुदैवतनक्षेत्रे गुरुधर्मसदानकाय गुरुपुत्रपरिताते गुरुपाखण्डखण्डकाय वेदसाराय वेदतत्त्वाय वेदगुप्ताय धीमहि गुणगुणकाय गन्धमत्ताय गोगत्राणाय धीमहि गुणातीताय गुणाधीशाय गुणपरेशाय धीमहि
एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि श्रीगणेशाय धीमहि श्रीगणेशाय धीमहि
Moving on with our program, I would like to kindly request our respected Honorable Chairman Sir to open the proceedings of New Horizons in Biotechnology 2023.
ঠিক আছে ম্যাম ম্যাম হ্যাঁ হ্যাঁ নতুনটা নতুনটা নতুন এসছে নাকি দেখো ঠিক আছে ঠিক আছে ঠিক আছে ওটাই তো আমাদের অ্যাবস্ট্রাক্ট গুলো আছে
গেল গেল গেল
ওটাই তো আমাদের অ্যাবস্ট্রাক্ট গুলো আছে না হ্যাঁ আমাদের তো অ্যাবস্ট্রাক্ট দেখলা তো ওটাই হ্যাঁ
Wow.
এইটাই তো বুকলেট আমাদের মাছটা না
আর এখানেই আছে
ঠিক আছে
ওটাই আছে
Now, we welcome our respected Honorable Chairman Sir, Dr. Lakshman Chandra Seth, TD, Founder and Chairman, ICARE Boldia. His vision has been the inspiration behind the iCare Foundation, under which numerous education institutions are scaling new heights, success with the rolling years. And still, the establishment continues to encompass today's youth under the light of knowledge. Now I would request Sir to kindly grace this podium and share a few precious words with us.
আমরা কালকেই করেছি মোটামুটি ছিল বলে
তাহলে তো ফার্স্ট ইয়ারে
ওটা থার্ড ইয়ারে সেখান থেকে একটা চ্যানেল আছে
আপনার যাওয়ার সাইডে চিঠি ছিল একটু জুম কর না
ঠিক আছে এটাই আছে
dignitaries on the dais and faculty members and our students, ladies and gentlemen. The subject which has been placed before you is very, very tough. Though it is easy in apparently, but it has serious depth in this matter. New horizon in the biotechnology. The biotechnology has got the manifold in direction. Recently, I will not prolong my speech because I am not expert in this matter. I am the student of history. Later on, I have done research in many areas which has been already published. I am not an educationist at all. I am a politician. Because from the very beginning of my college life, I joined the politics. I became a MLA of this area. Later on, I became Member of Parliament Lok Sabha from Tamaluk Parliamentary Constituency. So I know the politics. I know the impact of the politics in this society. But I have a little knowledge about any other subject related to the science. That is why I am getting much difficult to explain the biotechnology and its impact in the manifold horizon. Our experts are sitting here. They will suddenly explain and give you the good idea. The biotechnology, it has the no more is very newly this area has been seriously discussed and many things is being decided. The biotechnology, generally we have an idea, the technology which is a green and which does not have much impact on the environment. Nowadays, our environment is being seriously polluted by the emission of the industrial gas and so many other things also is responsible for polluting our environment. Recently, most of the people of the world became a victim of our corona. This is, I think, so far my knowledge concerned, it is one kind of incident took place because of the pollution of the nature, of the environment. Generally, there was a serious impact that whole globe will be destroyed because of the corona. But we think mankind is also more equipped and powerful nowadays. The mankind also can resist any sort of hazard in the environment. There was a serious rumor the whole globe will be destroyed. Practically, mankind, they have been so much equipped, they have resisted its serious impact. The environment which is being seriously affected by the mankind, in many folds. But this mankind is also so much equipped and knowledgeable, they have resisted the devastation in the nature. There are so many varieties of the devastation. Do you know, the mankind will be destroyed. But as a student of history, I know, but I feel mankind will not be destroyed. Mankind will be rejuvenated and also push back all the devastation. It has happened like that. Our environmental hazard which causes the corona or COVID has been seriously resisted by mankind. So it is proved that mankind is invincible. Mankind is invincible. This type of conviction you must bear in mind. So I think we will go ahead. So many medicine was discovered by the mankind. They have resisted this COVID or so many other diseases, cancer, diabetes, etc. So we have particularly I have a serious conviction that we will be able to fight back any type of hazard in the environment. When the COVID came up, we thought that the mankind will not survive, it will be destroyed. Whole globe was seriously affected. Myself was also affected. 3 times I was affected by corona. Somehow I have managed to escape. I don't know who has rescued me. Only the mankind has rescued me. Doctors, sisters, brothers, and their discovery has rescued us. So mankind is invincible. Mankind is not the conquerable. You have to keep in your minds. Otherwise you will not be able to fight back all the devastation. Biotechnology has its impact. The biotechnology nowadays has started discovering so many drugs and the medicine which is helping the mankind to survive. So this sort of conviction I have that we will survive. We will defeat any sort of devastation because of the so many ugly things. So our students, faculty members, and like us, we should think that we will be able to conquer the world. I will not speak long because I have little knowledge. Already I have told I am a student of the history. I know the history of the world, but I do not know the history how we will survive. The scientists, suddenly they can say, they can think, we can also think, but we cannot do that. But you are the student of science. You have to think that you will make the mankind survival. This sort of feeling we must have. I hope you will proceed accordingly. On the dais there are so many knowledgeable persons are sitting here. Suddenly they will enlighten us. I should not say anything which will be lucrative or which will be laughing. Because I have no knowledge about the science to that sense. Sense of an idea. I hope This area you must give your mind deeply so that you can help the mankind to survive. Today, those who are students, they will be faculty tomorrow. So you have a knowledge, but we have to deliver that. Students in our society are important element which we should not forget. Teachers are very much important. They teach and they guide our the students. At the same time, the students also deliver some idea which help the teachers to go ahead. I hope you will discuss this matter in this seminar, and suddenly you will give some conclusion. With these words, I express my greetings to all of you for inviting me to inaugurate this session. Thank you.
Thank you so much, sir, for enlightening us with your precious words. Moving on, I would like to invite Professor Shubhrata Mondal, sir, Principal and Professor NHBT Holdia, to share a few words on this seminar.
Good afternoon to everybody, respected Honorable Chairman, the dignitaries on the dais, my faculty friends, and my dear students. It's a great pleasure to me on for this auspicious day when one of our Department of Biotechnology, is now going to organize a national seminar on new horizon in biotechnology. Actually, Holdia Institute of Technology is a very vibrant and accelerated college where the students and faculty is always busy with some academic affairs. Teachers always organizing some seminar, conference from where student and teacher updated their knowledge. And our students is not only excellent in education, they are also excellent in sports, organizing events, etc. And in the year of 1996, when the college has been situated, this is the first private engineering college in West Bengal. At that time, it was a struggling one. Now it has become great and it has some reputation. And it is possible by the help of all stakeholders. And one brand value has been enriched in all corners of West Bengal as well as India. So my teachers, my faculties, my students always very much concerned on academic matters. Each and every day I am observing that one seminar, workshop, faculty department is continuing organizing here. From there, they have enriched their knowledge. And regarding biotechnology, we know it is a technology where it works on the living system, an organism. And not only that, it produces develop some products which help the human being, for mankind of the society. And at the same time, it always work on different fields in biotechnology in medicine, biotechnology in agriculture, biotechnology in environment, etc., etc. Not only that, biotechnology is such a subject, it is a interdisciplinary of applied science. Actually, research work is much more broad when the combination of different subjects will come up. Because when you research on chemistry, then there is some saturations. But when you mix with the chemistry, biology, then the perspectives will be high. So in this respect, biotechnology is a great opportunity. The students of biotechnology have a great opportunity to do research work, and for the benefit of the society. The recent trend in the biotechnology, that is, I think, work on the waste management, work on the molecular approach to the prevention of medicine disease. So I think the number of dignitaries they have who are experts on this field, they will highlight you will enrich your knowledge with these few words, and I expect the grand success of this event. Thank you all.
Thank you so much, sir. Next, I would like to invite Professor Krishnananda Chattopadhyay, sir, Chief Scientist, NHBT IICT Kolkata, to share a few words about this seminar.
Respected Chairman, I care, respected Principal, HIT, all the other faculty members who are present here, and all the students. And actually, particularly the students, because I personally believe that you have chosen a subject which would give you a real mileage in future. We always say in our science, when you choose a subject, try to choose a subject which is, you don't choose a subject which is working today, you try to choose a subject which would work tomorrow. Biotechnology is one of those subjects. I mean, there will be a lot of changes in the world as we go along. Like in 20 years, the job market will change significantly. There will be artificial intelligence. The robots are going to write codes. People would live very long. People would live 100 years, more than that. It's possible that you can choose your way of thinking. It will all happen because the medicine, the biology, the chemistry, the biotechnology is advancing at a tremendous pace. I'm just giving you a little bit of example. When we got our independence in 1947, the life expectancy of India was 40. Now it is 70. On average, Indian people live 70 years. It happened because of tremendous progress which has occurred in last few decades. And this will keep on growing. There will be tremendous advancement in biological technology. There will be a lot of jobs because people would live longer. And as people would live longer, they would be needing medicines. Infectious diseases are almost tamed. If you compare how many people used to die 20, 30 years ago in infectious disease, there's a huge number. People used to die. There are like millions of people died of leishmania, malaria. Now this has been taken care of. Although there was COVID issues and things of that type, but this infectious disease has been something that a lot of medicines, antibiotics. So there will be medicines, there will be therapeutics for many other diseases. So life expectancy will keep on increasing, and there will be a lot of booms when it comes to new medicines, genetic medicines. So biotechnology is a subject which would expect to give a lot of mileage in terms of new jobs, new development, and new career, which you may not be able to say in many booming fields, like even in computer science, as the artificial intelligence works. There could be problems there. But when it comes to biotechnology, I see bright future. That's kind of all. I mean, now people can do a lot of things. I mean, we had COVID, but then we had a vaccine in 1 year. This is remarkable. It's possible because this huge progress which we have made. Now we are now replacing almost everything. I mean, you name it, any organ, we can replace it nowadays. And which we cannot replace would be replaced in another 10, 15 years. Nanotechnology will join hand with biotechnology. You can have artificial kidney, artificial liver, and all made of synthetic materials. Those things are possible. And so I must congratulate you that you have chosen a subject which, at least in my opinion, has a real bright future. And I'm privileged that I have been invited to give a talk. And it would be, I think, I'm hoping, and I seriously would hope that this seminar is going to be a great success, and you will learn a lot many things today and tomorrow. Thank you very much.
Thank you so much, sir. Up next, I would like to invite Professor Nitin Chakrabarty, sir, President, Indian Photobiology Society, Professor, Department of Chemistry, Jadavpur University, Kolkata, to share a few words.
Good afternoon, everybody. The luminary Jongadas and my dear students and respected colleagues of this college and other colleges. As the President of Indian Photobiology Society, I would like to express my happiness to be associated with this program, which is really very interesting. Regarding Indian Photobiology Society, this is a national society, of course, Indian Photobiology Society, which was established in 1964, way back. The first president being Professor Sushil Kumar Mukherjee, Vice Chancellor. He was the Vice Chancellor of Calcutta University as well as Kolkata University, a renowned academician by that time. And first secretary was Professor Krishna Kamini Duhagi Mukherjee, one of the most eminent photo scientists in India that time. And I am happy, I was happy to be associated with her also. I got her as a colleague of my department. So I invite all the faculty members especially of this college and the area, and also the students and research scholars, to please go through our website of Indian Photobiology Society and become life member of the society so that you can know the detailed activities of it, and you will be invited or you will be informed about all the activities of the society. Among many of the works that we do, we often organize conferences from our end as well as associated partner of some other organizations, like here it is. We have also studied a series of lectures. Normally that is done or that takes place in the 4th Saturday of every month. So the next one will be on 25th of March, and next to next is supposed to be on 29th of April, this way. Some excellent scientists, teachers, they generally are invited, 2 or 3 maximum, and it's an evening program. So please be associated with Indian Photobiology Society and get the flavor of it. We have recently got a new executive council of the society, myself being the president, of course, and the secretary is one of my colleagues again, Professor Chittaranjan Sinha, who is coming here tomorrow, and he will be delivering a talk also. And we have the very active treasurer from this institute, HIT, is Dr. Gauri Shankar Rai Mahapatra of Chemistry Department. Of course, it's not a department of chemistry, and the department being Applied Sciences, something like that. So you can also directly contact Dr. Rai Mahapatra, Gauri Shankar Rai Mahapatra. He is here, I can see him, and you can consult with him how to become the member, etc., etc. Now coming to the program, I consider myself as dedicated for the students. So whatever anybody says about science, technology, blah, 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 everything is dependent on the students. You see, if the science, good science or good technology is given to a bad person, that good science and good technology takes a devastating form. Why? Science is the same, technology is the same, but it's the attitude of the person who is using it. So the first objective of all the students, everybody, should be to be good persons first, and then to use these things. So attitude, this is the most important word in life, in one's life. I sincerely believe it. So I have a talk also after some time, so I'm not going to take a long time here. Please listen to the other speakers, and then we can go to our technical session. Thank you very much.
Thank you so much, sir. Up next, I would like to invite Professor Bhashwati Pandit ma'am to share a few words with us. Good evening, everyone. The term biotechnology is not an unknown term to anybody in this audience, I think. So, 30 years back, when we were students, and this term was in the horizon of India, I mean, of course, by that time it had flourished in the Western world. So, when it was in India, a lot of technologists used to get surprised and think how biology could be a technology. They used to laugh. But I think in last 20-30 years, they have understood what is biotechnology and how biotechnology has brought a revolution in our daily life. And even if they had not learned it, I hope all of us have learned it in last 2 to 3 years during the pandemic. Everybody knows how biotechnology has helped to detect the disease, to cure the disease, and also bring vaccine like overnight. RT-PCR is no longer an unknown term. You may not know what is the technology behind RT-PCR, but you know that what is RT-PCR. So I think like these interdisciplinary subjects are very much essential nowadays, and it doesn't lose the flavor of individual subjects, but if we work hand in hand, that brings more knowledge and more ease in daily life. Just an example I'll give. When human genome sequencing was planned, meaning our genome is made of 4 nucleotides, and scientists wanted to know how these nucleotides are arranged. So human genome has 3 billion nucleotides. So it was not an easy job to get the sequence of human genome. But with time, technology developed, and it was amalgamation of biologists with computer science, with statisticians, with bioinformaticians, and this work was finished long ahead of time than it was planned. So I hope that amalgamation of different subjects will help and better our daily life, and not that it will lose the flavor of each of the subjects. So I hope the students in future will work hard to develop the subject and will bring new horizons in the subject. Thank you. Thank you so much, ma'am. Now, I would like to invite Professor Shubhrama Gupta, ma'am, to share a few words with us.
Good afternoon, everybody. Uh, it's an honor for me to address you all in this August gathering. First, I will like to express my thanks and gratitude to our Honorable Chairman Sir, who is a great leader, great educationalist, great visionary and philanthropist, and his enthralling speech is always a source of motivation for us. Next, I would also convey my regards to our Honorable Principal Sir, President of the Indian Photobiology Society. I also extend my thanks to Indian Chemical Society and Professor Krishnananda Sir of IICB, Professor Atin Kumar Mandor of Bosch Institute, Professor Anupam Sir of Indian Petrochemicals, and Professor Bhashwati Pandit from National Institute of Genomics, and to all other dignitaries who are present here. This time, this conference, New Horizons in Biotechnology, has been organized in association with our internal Quality Assurance Cell and Indian Chemical Society and Indian Photobiology Society. This is organized in every odd year since 2013. So this is the 6th time we are organizing this. Last times, in the 2021, it is due to COVID pandemic, it is organized in online mode. But now we are make this session a successful one. For this, I also extend my thanks to all the deans and HODs and all the other faculty members, staffs and beloved students for their presence and extends their support in order to make this program a successful one. The main objective of this seminar is to bridge the gap between industry and academics. Nowadays, it is also told that outcome-based teaching learning methodology should be practiced. So it is also another objective behind this seminar. And I am sure that students, they are having exposure, they will be having exposure in various aspects and attributes of biotechnology. I'll prolong my speech, but I will end up with the famous quote of Professor APJ Abdul Kalam: learning gives creativity, creativity leads to thinking, thinking provides knowledge, and knowledge makes you great. If this scientific session will ignite only one inquisitive mind, then I think that this session will be a successful session. I again extend my thanks to all the participants and wishes that this session will be a successful one. Thank you.
Thank you so much, ma'am, for your precious words. Now, I would request all the dignitaries to take their seats in the audience so that we can move on with the technical session.
সিনিয়র চাপ নেই আমার হ্যাঁ এই সিনিয়রদেরগুলো হয়ে যাক তারপরে তোদেরটা
যত আছে যে সব
হ্যাঁ দাদা পালা পালা আমরা বাঁচবো অনেক হয়ে আছি তোমার থেকে লাইভ করতে তাও বলছি তো রোহিতা কিছু বলবে না ও জানে এখন কিছু বসলে ও জানে এখন কিছু বলতে তুমি কি অবস্থা করবে না আমার পাশেরটা এবার ফাঁকাই ফাঁকি কাকে তোকে তোকেই বলছে তো ও ঠিক আছে ভাই 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 এইখানে সব না তোকেই বলছে তো তাহলে চাপ নেই
আমি যদি বসে বসে লাইভ দেখবে তারপরে ওকে কেন
आगे देखो नहीं सीनियर का भी होगा चापी तो नहीं তোকে তো ধরেছো তাই তো তোকে ধরেছে তুই ধরেছো
আরে আয় না সবাই দেখ পোস্টারে কি করবি আর পিছনে বসলে ও জিউস ওই আমার ভিডিও বাবা কি করছিস
বললাম
সাইডে জায়গা আছে
আমার কোনো জায়গা
ছেড়ে তো দেবে না তো ওই
এটা ফটো হ্যাঁ বাই বাই বাই
ওই শুভঙ্কর
বেরো 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 এটা ভাই রেকর্ড
ও শুভঙ্কর পিছনে
বলে কি শুনে যা
ও শুভঙ্কর
আরে আমার দেখা যায়
পিছনে আমি পিছনেই যাবো পিছনে আমি ভিডিও মুভি দেখবো প্রবলেম হবে আয় না তুই আচ্ছা দাঁড়া যাচ্ছে
কি কি হচ্ছে লাইভ দাঁড়া 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 এ রোহিত শুনতে পাচ্ছিল নাকি বললাম তোকে কি না বললেই হলো রোহিত ছিল বলে ভুলে বলতে পারছিলাম হ্যাঁ ওকে নিয়ে আমি যাই তুই তো নিজেই বললি এমনিতে বেরিয়ে যাবে ছাড় বাদ দে। ওর জন্য বেরিয়ে যাবে না বেরিয়ে যায় ওর জন্য তো বেরিয়ে যাবে ভাই সেমিনারে আছে এসএন বলছে হ্যাঁ বল 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 ওয়েবসাইট গেটের ওয়েবসাইটটা কি আরে গেট 23 গেট 2023 তো গেট আমাদের ফার্স্ট লিঙ্কটা আসতো ওইটাই
अरे भाई দেখে যাচ্ছে
কি হলো আবার? আবার 12টা বেজে গেছে নাকি?
চলছি বা কেন আমি বুঝতে পারছি না। এই এই সে বলো টান এটা,
কোনটাকে টান?
এই এটা বাবা একদম নিচে থেকে তুলে দিচ্ছে।
ছাড়ো ছাড়ো।
পাওয়ার বাটন উপর রেখেছিস
আরে যাই বলিস, পেছনে ওইটা সেট আছে, পুরো ঘুরবে। ওইটা রেকর্ড করা উচিত ছিল ভাই। পুরো লাইভ ঘুমানো দেখাচ্ছে। ভাই মোবাইলটা আটকা সায়ন, মোবাইলটা একটু খেয়াল রাখিস। অরিত্রটার মোবাইল কিন্তু কিছু বলে তোকে ঠাপানো। আমি কেন? আমি আপনি বলে রাখলাম, আমি জানি কিছু বলে তোর হবে।
কিছু বলতেও না পারি, না বললে না দরকার হবে।
Request everyone, please be seated. We will begin it shortly. Please be seated, everyone. We will now begin with the second technical session of this session. This session will be chaired by Professor Shubhodh sir, Principal and Professor of the Institute of Technology. It will also be co-chaired by Professor Dr. T.K. Jana, Dean and Professor, School of Engineering, Korea Institute of Technology. We will now flag off the second half of the technical session with a talk by Dr. Krishnananda Chakrabarty. We have prepared a few words in his honor, outlining his academic background and his numerous achievements. Professor Dr. Krishnananda Chakrabarty is currently a chief scientist and the head of the Structural Biology and Bioinformatics Division at CSIR, Indian Institute of Chemical Biology. His research group applies novel biochemical and biophysical tools with a particular emphasis on neurodegeneration and infections. Professor Chattopadhyay obtained his PhD degree from the Tata Institute of Fundamental Research, Mumbai. He then moved to the Washington University School of Medicine, St. Louis, USA for his postdoctoral research. Before joining CSIR, Indian Institute of Chemical Biology in 2006, he worked at Pfizer USA as a senior scientist. He is a fellow of the Royal Society of Chemistry and the West Bengal Academy of Science and Technology. He is also a fellow of Indo-US Science and Technology Forum, a recipient of the American Chemical Society Membership Award. He is currently the lead of the Biophysics and Structural Biology section of the Editorial Board of Communications Biology, a Nature research journal. Today, Professor Chattopadhyay will be presenting his lecture on the topic protein conformation, dynamics, and aggression, from test tubes to human diseases. I will now request Sir to please come up on stage.
কি হচ্ছে কি হচ্ছে ও হ্যাঁ এই তো 4 জন দেখছে এই প্রথম মনে হয় হাইস্ট ভিউ
Okay, I thank the organizers for giving me an opportunity to be here and, to talk to you guys. So, kind of try to keep it for the
এরম ভাবে
particularly for the students. So, stop me if you don't understand something. Don't get bored, man.
হচ্ছে আর লাইভ হচ্ছে
If you think you are getting bored, let me know. Raise your hand. তোমাদেরকে বলছি যদি মনে হচ্ছে বোর লাগছে একটু হাত তুলে বলুন then you can ask question.
সবাই হাত তো
Alright now, so I don't have a syllabus, which is a good thing. So I will just keep on talking until my 30 minutes over and I'll stop.
30 মিনিট
কি বুঝলে? বুঝে গেল?
করবো স্যার
Good. Alright, so I'm a teacher, right? So I'm a scientist, so I mostly, I don't get to teach much, so it may not be easy for me to, explain everything what I'm going to talk today, but I kind of have to depend on you. On who? On who? And jore bolo, shunte pacchi na. Good. Alright, so all of you know protein, right? Can you hear me? Yes, sir. Can you hear me? Yes, sir. Good. So, you can hear me. I will be more because there are proteins which, if they don't work, you cannot get it. Right. So, what are proteins? Everybody knows that proteins basically they work. In a cell, whatever works, they are proteins. Proteins work. They are the working class of physiology. They work. All proteins have a defined function. Okay. And they carry out that particular work, it should have conformation, structure. So you guys are, all of you are like higher secondary form, right? You guys are going to do something, kind of. So you know that proteins have primary structure, secondary structure, and things of that type. Sequence, these you know. You know or not? Yes. Oh, good. So the thing is, you have a structure. So earlier, people used to believe that one protein has one function. One protein, one gene, one protein, one function. A particular protein, I'll maybe talk a little bit later about this. It is no longer valid. But then, look at the function. In my talk, we'll be talking about non-functional protein. What protein? Non-functional. So protein has a structure or conformation. They can also run around like anything. They are dynamic. Okay. So you guys are not very dynamic. You're very shanto. Proteins are not shanto. They run around like anything. Okay. And the bad thing is, some proteins are like this. Some of them are very sharp. So, in a party, like somebody will have gone to a disco or something, everybody is dancing. You'll find 2 or 3 people, they don't dance. They would shy away. And that one person will find another person who doesn't dance. And then they will come together. Shy people, they like each other and come together. I would call it aggregation. People who are not very dynamic have a different conformation. They sometimes can come together and aggregate. And aggregated proteins are not good for us because many of them aggregate in our brain. And when that happens, this can lead to what? So biotech people, you know, aggregated people can lead to what? Disease. Give me an example. Hey, this guy knows. Alzheimer's disease. For example, Alzheimer's. A protein called amyloid beta aggregates in brain can lead to Alzheimer's. Another protein called alpha-synuclein can aggregate in brain can lead to something called Parkinson's disease. And then there are ALS. And then there are thyroid diseases. Some of these diseases are infectious. Like thyroid disease is infectious. Some of them are non-infectious. Or at least they are known not to be infectious. Okay. You know mad cow disease. Right. Mad cow disease is infectious. But Alzheimer's disease is not. Right. Right. She is getting good. That's all. Hello. Manjabi again. We made a good goal. We come. Right. You're getting more, right? Good. All right. So, so who knows? This is like who knows what? Which one? Are you got anybody? No? Yes. Good. Margaret Thatcher. So the Didimonis are not able to answer. They cannot answer. Okay. So who is Margaret Thatcher? Prime Minister of England. Give me more. Give me more. I give you more. Good. So somebody challenges. She is not the first Prime Minister of England. Who is the first Prime Minister? Anyway, I don't know. I didn't know. United Kingdom. No, UK. No. She is the first Prime Minister of UK. So and she's also they used to call her Iron Lady, right? Iron Lady. The Iron Lady, and the already done she was a chemist. She was actually a chemist, and a chemist. Let's forget about the chemist. So she had a medical condition. When she was old, she mentioned that if my mom starts writing a sentence, when she finishes, she used to forget the beginning of the sentence. That's Alzheimer's disease. And that was Margaret Thatcher, one of the strongest female personality of the world. Alzheimer's disease, it doesn't matter. You still can have a disease like Alzheimer's disease, although you can be Iron. The middleman, Muhammad Ali, another strong, had Parkinson's disease. Stephen Hawking, a person with probably one of the strongest brains. Some people compare him with Einstein. So, he had a disease condition, again, another neurodegenerative disease, ALS. So, what I'm trying to say is, it doesn't matter that if you are a strong political leader or a strong scientist or a strong sportsman, it can catch you. you can be affected by, afflicted by a neurodegenerative disease. The good and bad news together is only 10% of it is typically 15% is genetic. So even nobody in your family had it, it does not mean that you would not have it, or I would not have it. It's only 10 to 15% genetic. Mostly sporadic diseases is that was not good news. Bad news is none of these diseases have any drug. And I'm going to go into the ugly news little later. That's it. A lot of people used to believe. Actually, when I started working on it in 2006, a lot of people told me that, hey, this neurodegeneration is not a clear disease problem. We have cholera. But why are you worried about PD, particular disease? You don't have it. That's not true. And I'll tell you why. So, you possibly can hear a term dementia. And you would have definitely heard this term if you watch Bangla movie. So there was a movie called Bala Shuru. And you know that there are 100 different diseases which can lead to dementia. It's a old age problem, and a bad statistics I can give you that here, whoever we are, if all of us live 90 years, about 50% of us would have one of those diseases which can lead to dementia. Like if we are 100, 50 of us may have dementia or one of the related diseases. The bad thing is, even the worst thing is, the other 50% may have to take care of somebody who had dementia. You understand why it is a problem? And there is no drug. And there is not really a big chance of having a drug in another 10 years. Lot of money has been wasted, lost, developing drug without any hope. And what kind of cost? And then, so I'm happy to tell you that it's not an Indian disease, wrong. Now look at that, 9.4 million people in around 2015 data live with dementia in US and American subcontinent. 10.5 million in Europe. Compare that. In Asia, it was 22.9 million. More than double than the number of patients in Europe. Do you still think that we should not study dementia? Good. So, all of you speak Bengali? Yes. Oh, good. No, sir. No, sir. I'll speak in English and sometimes I speak in Bengali. And I translate it immediately. It's like English, occasional Bengali with subtitles in English. Okay? Alright. So look at this graph. This graph is important. The blue one is projected dementia population for developed countries. It doesn't really increase much. The number is up to 2050 when you are going to go out. You know, when I'm old. If I live in a developed country, my chances of having dementia is actually not that much compared to if I am, one of those bodies. Huge. So developing countries are particularly vulnerable. The total cost is about $1 trillion US in 2018. No diagnosis, by the way. You know people. I'm sure you have seen people with dementia. You cannot. There is no confirmed dementia. Diagnosis only after someone is dead. If you do an autopsy, you will know that he had that protein aggregated on him. Otherwise, there is nothing, you cannot do a blood test and tell that you have dementia. Or Alzheimer's, or these are all post-mortem, and the thing is, there are a lot of drug trials, many, all things, in recent years, in last 10 years. So, I see that. And then I say, all these diseases have a common phenotype, if I say phenotype. Proteins exist. Different proteins, but they exist. Now, since you are all biotechnology people, you would know, or you would guess, that it possibly means a protein which is functional. If it starts aggregating, starts becoming non-functional, the function which it is supposed to do, it cannot do, that leads to disease. It's an assumption which is good, but it's possibly not true. That is called loss of function hypothesis, right? But then there is also a thing is that this protein aggregation can lead to destruction of neurons in brain, that leads to cascades of events, gain of function. Now the thing is, which one is true, which one is not true, there are a lot of controversies. We are not going to go there. I'll talk about what I do. Now so protein aggregation can be studied experimentally, and this picture is this is an experiment. Sure. A hydrocarbon tea. If you add to the solution, it binds to a protein aggregate which is cross beta, meaning cross beta structure. Many proteins forms aggregates when it forms cross beta structure, or rather, they are also called fibrils, protein fibrils. You know that. Amyloid fibrils, everybody knows. I'm sure you have read it in your books now. And if you follow that finally, so x-axis is time, y-axis is alphabetic growth. If you follow it, you see that nothing happens, then look, you see lot of amyloid or lot of alphabetic growth. It's an easy experiment. It is an easy experiment. Of course, because it is so easy, there are a lot of studies on it. Then fibrils are also very stable. Okay. So, since they are very stable, people have done, you guys know like structure determinations by X-ray, cryo-electron microscopy, those things you have studied, right? So, since fibrils are well studied, their structures are also known. There are a lot of structures available of fibrils. Now, since structures are available of fibrils, there are a lot of drugs which have been discovered and developed against fibrils. The idea is they will target, those drugs will target fibrils so that the fibrils won't accumulate. These are good. Now, those molecules have been tried in good multi-billion-dollar clinical trials. Not one, not two, many, 10, 20, by big drug companies like Pfizer, GSK, all the big companies. The good news is most of the drugs have been shown that they don't accumulate fibrils. The bad news is they don't do anything on the disease. So what does it tell? They stop fighting, but they don't stop dementia or slow down dementia. What does it tell you? What would be your, get from that one? The result number one, those drugs stop fighting. Result number two, those drugs don't delay dementia. What would be your difference? Follow. Yeah. Say something. You have to given two results. One, these all these trials have been shown that they stop fibril formation. Number one result. Number two result, they don't delay dementia. From these two results, what would be your hypothesis or inference?
These experiments don't actually prove that dementia can be cured with these experiments.
With this fibril targeting drug. So, good, you are smart, man. The problem is, most of the many people, and some of them have actually got Nobel Prize, did not simply understand the simple. I mean, you can get Nobel Prize just because of that. Because you know, they did not. So they kept on working on fibrils, kept on fibrils. I mean, there are a lot of, you make a small molecules, you stop fibrils, you get a Jackson paper, and then it goes to clinical trial, you spend millions of dollars, and drug doesn't work. It basically tells, maybe the fibrils are not bad guys at all. They are actually not bad. And I think that's a very reasonable hypothesis. You know, a lot of these scientists did not, or did not believe. So they just kept on working. So we, আমি মনে হয় না তুলে তুলে জিজ্ঞেস করবো ও করে আর বিশেষ করে ভালো করে আশা করে দেয় তাদের বেশি কিছু ঠিক আছে so we thought maybe these are not bad guys maybe bad guys are here somewhere which forms earlier than the fight. The problem is they don't show you just like that very shy very quiet persons in the lab in the room. You know, the teachers are always very apprehensive about this guy who is not jumping around, but there is somebody who is very quiet, very used to that. It's very difficult to find them. They are here. The problem is, it's very difficult to find them because they don't show up. Can we develop method by which you can see those unseen molecules? Can you develop methodology by which you can find those molecules really useful and they won't show up molecules? That was our research. At the beginning, and basically that has been our research. The problem is, so you have, say, 1 micromolar of protein in a test tube. See, remember my talk? Test tube disease. Say, you have protein in a test tube. How many molecules are protein in a test tube? Biotechnology students. 1 molar protein in a test tube. Tell me, how many molecules? 6.023. How many? 10 to the power 23 molecules. And God knows what they are doing. They are just jumping around doing all kinds of things, right? So they are extremely heterogeneous. And maybe 5 of them are not. How? And then we are all, it's a democratic country, we understand the democracy. So if 10 to the 20 molecules are good, and only 10 to the 3 molecules are not doing good, you won't be able to see it. Right. We believe in most of the average biology, the conventional biology believes in average. Whatever is the democratically acceptable outcome, that's what we believe. So So we think there is no aggregation, everything is good. We don't see those few molecules which are actually not good. Because we don't have a technology to see it. However, if we can develop technologies by which we don't study 23 molecules, but one molecule. Can we see every molecule in that test tube, or in human tissue, or in the brain? Then we can actually see all of them. We can study them separately. That's called single molecule spectroscopy. Single molecule spectroscopy. Not 10 to the power 23 molecules. Everywhere. So the heterogeneity, which is basically the bread and butter of biology, can now be more effectively resolved by using single molecule spectroscopy. And that is exactly what we have been doing. And that's our only hope. See, you can see all molecules, you can see all those very shy molecules which are separating out. They don't mix with the common people. So that's what we did, and I don't want to give you all the details about this, because this is just technically quite complicated. You require a certain amount of optical setup, this thing, that thing, and then you have to find out. So this kind of measurement requires physics, chemistry, biology, and mathematics. True combinations of and some amount of engineering. So, if you come to our lab, for example, you are expected to learn biology, you are expected to learn a little bit of physics, little bit of chemistry, and mathematics, so that you can do these experiments. And not only in our lab, there are many. There are also many of them are called biophysicists. So the idea is simple. You have a protein, very elongated, unfolded protein. You know the primary structure of a protein. Has no structure. Now, you take the primary structure or the unfolded protein, you make the protein fold, you make contact. If you do a little calculation using something called a polymer physics or chemistry, people who are really getting bored, let me know. If you do a calculation, I'm not asking you the calculation though. What you can do is you can find out for 100 proteins, it takes you nanoseconds, like 200 times. And while it is forming a compact structure, there are many other things that happen. Like it's also forming the secondary structure. The protein was supposed to be heavy, started becoming heavy, or it started becoming shape, or it started becoming all kinds of things. So we have found out that, I'm not getting into the detail of the data because there is no point, but what we found out is that if a protein forms this chain, make this contact really fast, sometimes they tend to make mistakes. If they actually go really fast, they tend to make mistakes. So supposedly, it's supposed to be a beta sheet, they could have become a helix. And if that happens, it has to be corrected. So it has to unfold again before it can fold back into the right conformation. So you understand. So there are all kinds of things which go on, and if they cannot make that correction, they start aggregating. So in the early stage of a protein folding / aggregation landscape, how many conformations you get? 1, folding. 2, a collapse, which may or may not have the right secondary structure. 3, a secondary structure wala conformation. 4, aggregates. You have all those 4 possible choices. And if you have a spectroscopic techniques which can resolve all these 4 possible conformations, you can study how that protein is going to aggregate. And you don't have to depend on one technique of, high-field formation using carbon. We did that. Whatever. These are the techniques and how I do it and things like that. Yeah, I'm not really about it. So I'll go into this. So you have this, an extended protein, you have a collapsed protein, and you have those oligomers. I will call them oligomers, which form early, not the fibrils, which are late, early oligomers, and the structure, voila. And the question is, okay, fine, you say all kinds of good things, and these are mostly like a lot of mathematics there, a model. How can you prove it? You can. And if you want to prove, there are tricks here. Like, so now your question is becoming conformational fluctuation, a protein which is breathing in microsecond time scale, that you have to measure, and then a protein called not efficiently breathing and start forming oligomers. And you can separate it. Like A is a collapsed protein, instead is an extended protein, O is a oligomeric protein. Fluctuation, oligomerization, and you can have an equilibrium. And all of you know how to solve equilibrium equation. We did too. And we did all kinds of funny results. For example, these two proteins, which they look exactly very similar in secondary structure and in tertiary structure. They are both actually cytochrome C, but one of them from yeast, another is from mammals, and they look differently for their secondary function. What is secondary function? Primary function of cytochrome C is electron transfer. Now I say one protein, one function may not be true anymore. Cytochrome C is one example. Secondary function is basically the initiation of apoptosis. You all know. And that secondary function varies for yeast and for mammals. Although both of them are eukaryotes. Although they have very similar structure. And how they vary, people had no clue until we showed them. There, we call them permeability binding and stability landscape differ significantly. And this could be possible because of this single molecule resolution we have. If you superimpose them, they're exactly superimposable. I'm sorry. If you put them together, they're superimposable. So structure is not an issue. Dynamics is an issue. But, and then that very, very dynamic piece cytochrome came from that lot of positive charge at the surface and lot of negative charge at the surface or east. So since you have a lot of positive charge, they don't like it. They want to separate them. Say again, lot of negative charge at the surface. So there are two regions. One of them is very positively charged oriented, another is very negatively charged oriented. So they are inherently very unstable. Now look at it, at least evolutionary older, but then whole residues, nature has changed at the surface, which did not make any change at the primary structure, but what they did, they distributed the charge more uniformly at the surface. 4 changes, only 4 changes. Now, it has a huge implication in the mammal, or the secondary function of mammalian cytoplasm. That's right. So what does it tell you? So nature is very careful what are they changing, how much cost it has to pay, and what kind of function it has to get out. Anyway, this is alpha-synuclein. Alpha-synuclein is a protein which aggregates in Pg. And it aggregates because there is a NAP region, it's a very hydrophobic region. Hydrophobic residues, they like to stick together. However, the cell terminal and main terminal, they are charged. They try to balance so that the normal protein does not exist, but any change in that balance would be desired. What I'm trying to say is that we have actually done experiments to show that all those conformations which I wanted you to believe before by mathematicians, they can actually exist. You have this extended structure, collapsed structure, secondary structure, polymer, and things of that kind. They do exist. And you can actually see it by experiment. Not only that, which makes it even more interesting, is that now you can use technology like bioelectron microscopy. And we have found that in the lab, by which you can get structure of those very early oligomers, which used to be invisible before. Since they could not be seen, since there was no structure of those early oligomers, remember those early oligomers which don't show up, there was no drug. Now we know the structure of those early oligomers. Not only that, last week we actually published the very first structure of those early oligomers internationally. Nobody has done it before us. Last week, the second structure has come. If you compare that with 5 years, there are 100 structures. Now at least there are 2. Since you have more structure and there will be more structure on the way, people can, drug companies would now make molecules which would target not the fibrils, I'm stressing it again and again, not the fibrils, but the oligomers, which would supposedly more toxic. Now they have a way of targeting them because they know the structure. Now hopefully they can have better drug. Hopefully they can have a solution for this problem which has the potential to bother a lot of people when we would be 90 years old. Hopefully we may have a solution. I'll stop there. Thank you. Anyway, I would like to thank many people, and then one of them is my what so many beautiful work in the lab, and then I had collaborations with other university, Bose Institute, University of Texas, Austin, NIT, Bhubaneswar, and other places. I haven't put it. Thank you very much for your very patience, listening. You have any question? I hope you do. No questions? Yes, sir. You have a question. Look,
my course will have small time memory loss problem. That can lead to the dementia. What are the causes and what are the diagnosis for that?
you don't have that. Alzheimer's disease can happen early mostly if you have a genetic component. Alzheimer's or Parkinson's happens at the older age. Sometimes neurodegeneration can happen early, but mostly when you have a genetic predisposition. However, I think last month there was a rather sensitive news of a dementia patient. I think it was like 37 years old. So it's not easy to understand why. I cannot answer your question obviously, but I don't know. But a lot of people think that more we torture our Mother Nature with interesting things like pesticides, pollution, feeding human flesh to human, or cow meat to cow, those things would happen. Why did I say these two sentences? Because for prior disease, mad cow disease, they used to feed cow meat to cow. Or Kuru, one of those prior disease which is prevalent, used to be prevalent in Africa. The winner, if there was a war, the winner would eat the victim or the loser. So one of the hypotheses was certain things like if we deviate too much from the normal way of living, there will be chances of these things. It's a hypothesis. We don't know. We don't know what happened to that fellow who had this 37. Don't remember exactly. But there was a very interesting case. So I don't know. But of course, if you think that you're forgetting things, maybe you should go to a doctor, not to a scientist. Yeah. Anything? Yeah. Yeah, sorry. Yeah.
Asia was leading.
Yeah.
Why? Why is it the Asians who are more prone to these diseases compared to others?
I don't know.
Is it the diet? Is it the diet environment? What triggers it?
I don't know. I mean, if I knew, I would have been good for me. It's a very difficult question to answer. The problem is we don't know nobody knows the exact mechanism why these diseases occur. Food habits may have a role to play. I'll give you an example. May have a role to play, meaning there are trials which show, but there is no definite proof though, which indicated that if you drink coffee twice, black, strong coffee, your chances of getting disease is less. Or if you smoke, for that matter, people who smoke, that's good news. Absolutely. And please don't record this. Apparently, smokers have chance of getting less people. I don't know whether that means that you die early because of smoking, or you really have less chance of getting. I don't know. I haven't read that. But food habits, weather, amount of pollution you are experiencing yourself in may have a role to play. Also, unless we know the exact mechanism of these diseases, which are not easy to do, yeah, that's a good question. Yes, sir.
How you will characterize by aggregation of intercellular protein caused by abnormality in protein folding?
Yeah, that's what I'm saying. So the aggregation, like we use this particular technique which can give us a single molecule. So basically what we do is we label that protein with a very bright dye, very bright, so that I can detect it even when it's very low concentration, which I did discuss today. Yes, sir.
Sir, what are the basic differences of oligomers and fibers?
Very good question. I didn't expect this question. Very difficult, very important question actually. So, let me. So the fibrils are typically cross beta. Can you go back? Go back. Go back. Next one. Yeah, this is a movie. Can you see that video? Yeah, can you see that? See, this oligomer, this oligomer which we got the structure is like, did you guys go to KFC? KFC. What is KFC? Potassium? Cyanide, huh? So you go to the KFC, right? You eat drumsticks. You get drumsticks. Yeah, our oligomers, they look like drumsticks. And they have a head and they have this here. So what happens is that that oligomers are kind of distorted head compared to a fibril which forms. And in the secondary structure is here, there was a change in pole. The fibrils are mostly cross beta and anti-parallel beta, while the oligomers, the toxic ones are parallel beta. Then there is also a non-toxic version, which is anti-parallel beta. I mean, I have been confused a little bit. Something like that. But there was a big change in whole, the secondary structure, and which we could study by using FTIR. And there are other also like that. But good question. Thank you. Okay. I think I'm done. Thank you.
Thank you, sir, for this interactive session. Now I will request Shayantari ma'am, who is a student of Krishnananda sir, to please come up and hand over our eminent speaker with a token of gratitude.
ওইটার জন্য স্টার্টআপের জন্য টেনশন হয় না নাকি জানি পাস করতে পারবো আরে ক্লিয়ার হয়ে যাবে হ্যাঁ রে চাই তো তুই জানি একটু দিতে পারবে
Next up is our esteemed speaker, Professor Nitin Kumar Chattopadhyay, whom we wish to honor with a few words describing about his academic background and listing his numerous accomplishments. Professor Nitin Chattopadhyay obtained his bachelor and master degrees from University of Calcutta and PhD degree from Jadavpur University, working in Indian Association for Cultivation of Science. He joined the Department of Chemistry in Jadavpur University in 1991, where he had been a professor since 2006. During his couple of postdocs, he worked in Catholic University of Leuven, Belgium, and Coimbra University, Portugal. His areas of specialization encompass photochemistry and spectroscopy, biophysical chemistry, surface chemistry, fluorescence sensing polymer photophysics, photoacoustic calorimetry, etc. He is a well-experienced teacher as well as researcher at the same time. In recognition of his scholastic, well-acclaimed teacher, he has been endowed with Shikha Ratna Award from the Government of West Bengal in 2019. His quality research is recognized globally. He had been a fellow of Indian Bengal. His quality research, He has been a fellow of Indian Academy of Sciences, National Academy of Sciences, and West Bengal Academy of Science and Technology. He is a recipient of the Bronze Medal from Chemical Research Society of India. Today, Professor Chattopadhyay will be presenting on the topic, which is development of potential strategies from simple ideas.
Good afternoon, everybody. Once again. So it's very difficult to be the last speaker because you are all tired and the hall is empty already for logical reasons because they have to return home. Anyway, I am not going to describe anything in detail. You may be remembering that Dr. Lokhan said in his very nice talk, he said, repeatedly he told, that he is not going to elaborate or elongate his talk because he doesn't know whatever he has said or he is going to be said, it is just from common sense. But you have already felt that the talk was very good. So there lies the importance of this common sense. I always say to the youngsters that common sense can solve almost or at least 80% of any problem at any level. That's the strength of common sense. But unfortunately, common sense is not very common. That is the fact. So here, my whole intention is don't depend so much on sophisticated instruments, costly instruments. 90 to 95% research is done here. You need crores of rupees for buying costly instruments. But you can use those things properly only when this thing is very efficient. Otherwise, it goes all in vain. So I will be giving some demonstrations only from my own lab. Okay. Any one of you or all of you are encouraged to contact me at this email, simple name, in between there is dot, @yahoo.com, or even you may contact me with my mobile number. Just type this name in Google search engine. It will take you to my site. Their mobile number is also given. So basically the title goes like development of important strategies from simple ideas, basic ideas. You will understand that all my research, most of my research, the basic idea comes from higher secondary level or at the best graduate level. And some of them are already published in world's best journal. I'm just using the word best journal. So let's go. This is for sensing, why is it so slow? My God. Just one moment.
নিজের না না চশমা কেন নাকি ও চশমাটা পরেই আছে যেটা ভাই সেটা হলো
So what is sensing? Sensing is the detection and or estimation of pollutants in analytes or essential or fatal metal ions in bloodstream. You have to detect its presence and also the quantitative measurement of that thing. These are very important. Like we need to know the concentration of arsenic or even presence of arsenic in water, cyanide, potassium, sodium, copper, iron, etc. In this example, we just try to measure this copper. What was the idea? Okay, for sensing purpose, we have different methods like liquid chromatography, potentiometry, capillary electrophoresis. There is something problem there.
problem দেখছি
Yeah, that's better. I don't know why. In that case, my mobility is stopped. Okay, but fluorescence is most effective one because it's very sensitive. Fluorescence is one of the most sensitive techniques available till now. So now, a substance has some fluorescence and we can use it as sensor system, sensor molecule. So what happens? Say for example, with the addition of analyte, as we are increasing the analyte concentration, the intensity of fluorescence goes up. So from that, we can detect the presence and also estimate the quantitative way its concentration. So this is called enhancement-based sensing, and on the other way, there can also be quenching-based sensing. What are the major criteria of a sensor? It must be selective. It should react to only one species. Then only I can say that, okay, this is present or not. The other one is sensitivity. There must be a substantial change in the observable with a little addition of the analyte. Otherwise, it doesn't give any meaning. Now about selectivity, whether a particular sensor will respond to somebody, that is, we don't have any control on it. It's a matter of luck. But about sensitivity, we can change the molecule. Normally they are all organic molecule, we can change the molecule. So it undergoes synthesis. But for people like me, it's cycling. But we can use the general idea of modification of the environment. What to do? So we wanted to enhance the sensitivity of a sensor for copper tremendously using a very, very, very simple idea. What is that idea? Our approach was modification of the environment. Basically, what we did is simply we introduced some broker. Do you know what is broker? Yeah, say for example, I have gone to a city, new city. I need to stay there for 1 year. What should I do? I will look for some place, some flat maybe. But I do not know which flat is running vacant. In the opposite side, there are plenty of flats lying vacant, but the owners, they don't know who is going to hire. So what do? We approach a broker. Okay, the owner also give him some information, and then I go to him, and handshaking is done. It's exactly the societal picture that we have translated or transformed into science, and that led to this paper, a paper in Journal of American Chemical Society, which is the best journal in the world in chemistry. Publication in Journal of College and Interface Science, which is also a very good journal, not the best, very good journal. And this journal, the second one, reports for the first time in science where a cation senses a cation. That is the first report in science. So what did we do? Yeah, these are the two publications. So the idea is very simple. Why sensing of copper ion was so little, so inappreciable? That is because copper ion that stays within blood or that we took in water was in the range of micromolar. So one molecule surrounded by lakhs of molecules of water. That is 1 micromolar. And the sensor concentration is also 1 micromolar, in the range of micromolar. So there also it's very low. So what is the meaning of emission? You excite some molecule, the sensor molecule, and it fluoresces. That means it goes to the upper state, excited state, it stays there for some time. What is the time? 1 nanosecond. So if within 1 nanosecond, the analyte, that is copper ion here, comes there to interact with the excited fluorophore, then only fluorescence will go down because the energy is taken out, snatched up. The problem is it has only 9 second lifetime. So within that time, it's very difficult for the copper ion, which is lying far away, to reach it. So what happens? The quenching efficiency is very small, very low. What did we do? We used some broker, myself. We used anionic or negatively charged micelles. So what does it do? The micelles are units with negative charges, and when there is a micelle, this organic dye, which is the sensor molecule, it is adhered to the surface of the micelle. So now the water, this dye molecule is not floating on the water; they are just sitting on the micellar surfaces. Now micellar surface being negative, all the positive copper ions, they are pulled towards it. So now this copper ion and the dye molecule, sensor molecule, they are sitting just side by side. So whenever you excite the probe, the sensor molecule, immediately copper is very close, copper goes there and takes away the energy. So quenching efficiency is enhanced tremendously. You see? So this way, this is the concentration of sodium dioxide sulfate, very common. This is one concentration. You perform the experiment which is known as this Stanhomer experiment, and we get something like that. So at this CMC, critical micellar concentration, you get enormous enhancement in the sensing ability. So that was the first report. And in the second one, our question was, can we extend this idea for any application concept? So is it possible to sense or determine or detect copper ion if I use a cation? You see, this is the cation, but this is counter ion. So this is cationic species. Is it possible to sense copper ion with this molecule? Phenolphthalein, it is called. Yes, we got it. And if you just look at these 4 figures, what we have changed it? We have only changed the carbon chain. Sodium dodecyl substitute is the dodecyl. Now we have taken sodium octyl, 8, 10, 12, 14. Only carbon chain length of the surfactant is increased gradually. And you see here, the patterns are all the same. So variation patterns are the same. But here it is 240 times increase, here 800 times, here 3,200 times, and here around 14,000 times increment. So the basic idea is choice of sodium N, SNS basically, N is variable. This surfactant of proper chain length and optimum concentration can enhance the sensing efficiency towards copper. And this is the first report in science where it was reported, or it is reported, that a cation can sense a cationic species, which was hitherto impossible. Because what is the idea? In solution phase, when a cation goes towards or it approaches towards another cation, there is electrostatic repulsion. So they cannot come closer. They cannot come in contact. So how can one sense the other one? So I don't know, the time is quite long. I think we should stop here. You people look very tired. We have so many things here, but better to stop. So I stop here. Maybe sometime in some other occasion we can meet and we can discuss a bit also.
Thank you, sir, for this interesting session. Now, I would request Dr. Shuchita Das Maji ma'am, Associate Professor, Department of Biotechnology, Haldia Institute of Technology, to come up on stage and facilitate sir with a small gesture of appreciation.
এরকম ভাবে কি আসবে? আরে রাধা মতনই রঙ কিছু আমি বললাম ওকে কিছু বলেছি আমি বলিনি কিছু আমি বলিনি কিছু
So this was the last offline session for today. But we have one more speaker for today's technical session that will be held in online mode. It will be my pleasure to introduce all of you to the final speaker of the day, Dr. Abhishek Maha. With a few words, I would like to honor him by outlining his academic background and his various accomplishments.
ওই দাদা অনলাইনটার পর কি এটা হবে নাকি বন্ধ করে দেবো অনলাইনে আবার জয়েন করতে হবে আবার লিঙ্ক বানাও আবার জয়েন করতে এবার সৌরদীপ্তটা চাঁচালি কিন্তু আমি কিছু জানি না আমার বাবা
আমি তো এরকম করে আমি আর কিছু উল্টো পাল্টা বলবো কে বলছে হবে না হবে না ও তো কিছুই জানি না
গজব পিছিয়ে এই রনি এটাকে স্টপ কর এখন অনলাইন হবে এটাকে এখন একটু স্টপ
বলতে হবে ম্যামকে জিজ্ঞেস করে
You would request the audience to stay seated Our speaker is joining in the online mode. Till then, please be patient and be seated.
ভাই ভাই সবাই খেয়ে দিয়ে এসে গেল কি খেয়ে এলি
এলাম তোমাকে দেবে
কি শুনতে চাস কানে নিচে ফ্ল্যাশ করে দাও মারো না কি কি শুনতে চাস বেরিয়ে যাবে পকোড়া কফি দুপুরে আর কি খেলাম
চা খেতে খেতে হচ্ছে একটা খাবার খেতে শুনে হ্যাঁ আমি একটা কত প্রশ্ন আছে 8টার সময় আমি বাড়ি যাবো সৌজত্ব দাঁড়িয়ে
এটাকে বন্ধ করবো কেন
ওটা চলবে
কেন
এদের শেষ হবে তারপরে সব শেষ হবে তারপর ওটা বন্ধ হবে আমার ফোনটা শেষ হবে
আরে আমরা সৌগত রইলো ফোনটা নিয়ে চলে যাবো আমরা আমার কানে সব আমি শুনেছি সব রুমে যাই তারপর একটা বলছি হ্যাঁ হ্যাঁ শুনতে পেয়েছি
শুকে নে মোজার বন্ধটা
এই জন্য বলছি তখন যেটা বিচ্ছি মজার গন্ধ দেখতে আসছে
আমি সকাল 7টা থেকে
এটা নিশ্চয়ই দুদিন ইউজ করতে চেয়েছি আমি তাই বলছি একটু বাসি লাগে
এসি তো বন্ধ করে দিলাম ভাই ঠান্ডা লাগছে বলে এই চালা রে এখন গরম লাগছে আমার সিয়ার কে দেবে ও সিয়ার তো নিচেই আছে ক্ষুদিরামে থাকে আরে না নিচে সব খাচ্ছে ভাই ভাই হ্যাঁ এইটা একটু মানা যায় সার্ভার ক্র্যাশ করে গেছে আইআইটি সার্ভার ক্র্যাশ করে গেছে
বাড়িতে থাকি হোস্টেলে থাকি মেয়েটা পাহাড় থাকি
কি বলতে বাইরে থেকে কি
স্টুডেন্ট পার্টিসিপেট করেছে
হাতের কাছে পড়েছে আমি কিছু মেরে দেবো কিছু কিছু
তাহলে তো সিলেকশন হয়ে যাবে কত কাটা যদি বাড়িয়ে
সকাল থেকে চলছে খুব কষ্ট রেখেছে আমার মা কোনো চালাতেই চায় না কখন কথা নিয়ে এখানে
হ্যাঁ 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 এটা আমি অনেকক্ষণ থেকে দেখছি ভাই
সুকন্যার কাছে বার করবি
হাতে বুঝিয়ে দিচ্ছি
একদম কাকিমা গুলো সিসিটিভি
সবাই করে
কি করছিস?
সৌগত পেছনে চলে গেল আপনি আসতে আপনি কিছু বলছেন না আমি তো বসে বসে কফি খাচ্ছি না এই মনে একটু বলি আমাদের এইসব করে লাভ নেই আমাদের কালচার প্রোগ্রাম আমার বাড়িতে কি চলছে আগে মতো হবে ও না তখন তো ট্রেনিং জুলাই যদি ফার্স্ট থেকে শুরু হয় জুলাই আগস্ট কাজ শেষ না হলে আমরা সেপ্টেম্বরটাও নেব ছাড়াই হয়ে যাবে টিচার্স হ্যাঁ একটা 2 মাস না দুটো 2 মাস বাকি এক মাস এদেরও রিজোর্স স্টুডেন্টেরও 2 মাস ছাড়া কি টিচার্স গান যায় তো এতগুলো হতে ছেলে বলে কি আর নামকে যে গান করবো হ্যাঁ এবারে কি আর তোদের মধ্যে কেউ গান করতে যাচ্ছে সবাই নাকি জন্য গান করে না আর এই বছরই এসিএফটা আমাদের হলো এতগুলো প্রাইজ ওই দিশা এই তো আলাদা হয়তো চলে আসবে আরে ঠিক আছে এর খাই কালকে কত রাত অব্দি জানি পোস্টার নেই ওদের কি যেন মুহাফা বলতে এই তো মিটে বল বল তুই ওই দায়িত্বটা ছেড়ে চলে এলি দায়িত্বটা ছেড়ে চলে
আরে কি
এই কালকে ফর্মাল ড্রেস আমি কলেজে
क्या करी भाई 4000 रुपए
অনেক কিছু হবে সারা রাত কত টাকা নিচে বলি 10,000 টাকা নিচে না চশমাটা এই 10,000 টাকা চশমা এই তো কত 10,000 টাকা চশমা হ্যাঁ কত 5,000
এই অর্ধেক এটা না আসে
ওই নরম জায়গা মাছ গাড়ি সব জায়গা মাছ আমাদের খেলা দিতে বলা যা বলবে মানে শেষে বলবে অভিষেক মহাপা কোথায় মেন হ্যাঁ টাকলু পাড়া একটা ছেলে
नहीं होगा कल को হবে না বাবাকে তোকে বাংলা কেন বলতে হচ্ছে আচ্ছা তাই দেখে বলছিল কালকে হবে না পরে ডিপার্টমেন্টে করতে হবে
কাকু কোথায় চলে গেল
ওই ম্যামটা সব কিছু করেছে ভালো
ভাই আনন্দে একদম বাদ ভেঙে গেছে আরে দাদা রাত্রিবেলা আবার ডিপার্টমেন্টে বসে গিয়ে বলে তো তাকে দিয়ে
এরকম
এই কি করছিস তুই এদিক ওদিক সরে দিচ্ছিস আবার লোক উঠে এদিকে চলে যাচ্ছে আমরা সবাইকে দিই আমারটা নেবো কি করে বল জনের কাছে ভাবিনি পাঁচের লিখে আমি ভাবিনি
Thank you everyone for waiting. It will be my pleasure to now introduce all of you to the final speaker for the day, Dr. Abhishek Mahapa. With a few words, I would like to honor him by outlining his academic background and his various accomplishments. Dr. Abhishek Mahapa has completed his graduation and master's degree in microbiology from Vidyasagar University, West Bengal. He was awarded PhD in Biotechnology from Maulana Abul Kalam Azad University of Technology, West Bengal. During his PhD, he has structurally and functionally characterized a global virulence regulator from Staphylococcus aureus as a potential drug target. After completing his PhD, he joined as a DBT Research Associate at Molecular Biophysics Unit, Indian Institute of Science, Bangalore. His postdoctoral research was aimed to study the mycobacterial second messenger signaling, where he investigated the proteins involved in second messenger regulation. He is currently a senior scientist at CSIR IIIN Journal. His long-term research goals are to understand mycobacterial stress response by second messenger signaling, bacterial antibiotic resistance, bacterial biofilms, screening, and mechanistic study of antimicrobials against escape pathogens. His area of expertise lies in the fields of microbiology, molecular biology, biochemistry of bacterial proteins, mycobacterial second messenger signaling, bacterial biofilm. He has his publications, several renowned journals like Springer International, Bioinformation, PLOS ONE, and Protein Journal. Without further ado, I request her to take the virtual podium and present an interesting session on regulation of a mycobacterial CTI-AMP synthase. Thank you.
Okay. So, good evening, everyone. Am I audible to everyone? Okay. So, thank you for this kind introduction. And I was just looking at your brochure for this seminar, and I find out that after that you have poster sessions. So, I still remember my days at HIT when I was also a presenter of the poster. And from HIT I did my PhD under the guidance of Dr. Kyam Saunam. And I am basically thankful to everyone, especially Kyam, for giving me the opportunity to talk in this seminar. So without taking any more time, I will just go to the presentation. Let me share my slides now. So, the slides are visible. So, just 1.5 years back, I have joined this institute, Indian Institute of Integrative Medicine, and as a senior scientist in the infectious diseases division. So, which I am going to talk about, I have carried out at IISc Molecular Biophysics Unit during my postdoctoral days, and I have entitled my talk as Regulation of Mycobacterial Cyclic Synthesis. So, the next slide, the first slide basically will give you the introduction about how second messenger signaling works. So we all know the bacteria are continuously exposed to different type of environmental stresses. Like there is nutrient stress, pH stress, and also starvation. And these external stresses basically act as a primary messenger, and in response to the stress, this surface bacterial surface protein, actually the membrane protein, responds to that stress input, and which further induce the production of this second messenger molecules. And when the second messenger molecule are produced in cell, they bind to the different type of receptor proteins like the transcriptional factors, RNA target, basically RNA ribospecies, and there are other receptor proteins, which in turn is generated a different type of responses to overcome that external stimuli. And when the function of the cyclic, that nucleotide molecule, basically second messenger molecule finish, they are basically degraded by this phosphodiesterase molecule. They are basically degraded by this phosphodiesterase molecule. So there are several type of second messenger molecule present in bacterial chlorine, like cyclic dinucleotide, like cyclic GMP, cyclic AMP, or cyclic GAMP. And the old ones, like we all know, cyclic GAMP, cyclic AMP, and the mononucleotide derivatives like PPP. So these second messenger molecules can work quickly or can work alone to regulate any stress when bacteria encounter to any stress. So now I will talk about the discovery of cyclic dietary molecule. If you see the timeline of second messenger discovery, this molecule is very new, cyclic dietary, which I am going to talk about today. It is discovered in 2008. There is a group in Israel who are studying the functional regulation of why is protein from Bacillus subtilis. So they knock out this trait and studied their effect on Bacillus subtilis physiology. And they found that this protein has no effect on cell division, sporulation, or competence. But when they treated with DNA damaging agent, they found that more spores are formed in total, but less viable, the spore are less viable. And they did some simultaneous functional studies, which actually by which they showed that YS participate in damage checkpoint prior to sporulation and delays checkpoint activation in the case of any DNA damage. So they established the role of this protein to DNA damage control. So this protein is further renamed as DNA integrated scaling protein or DSA. And this all happened in 2006. And in 2008, a structural investigation of thermocouple DSA, they found additional residues, additional density at the core of the protein, which was further characterized as cyclic diamine. So I will talk about this structure a little bit later in my slides, specifically the TNPS structure. So now I will go to the regulation. After that, there are many discoveries or many studies happened with cyclic diamine in microbacterial system. So how cyclic AMP regulate microbacteria or regulated in microbacteria. So after induction of any intercellular or extracellular signals, this protein is known as DAC that consists diadenylate cyclase. This protein actually basically known as DSA, and this protein can produce or can catalyze the synthesis of cyclic AMP through ATP or ATP, and which in turn regulate different types of cellular phenotypes like cell morphology, metabolism, pulse response, or different type of DNA repair mechanism. And one interesting features of the cyclic molecule is they also able to induce when secreted outside the cell during infection. They actually help to induce host immune responses. So there are two aspects. In one aspect, this molecule regulates different bacterial physiology, and it also helps in induction of host immune responses. And apart from these functions, there are several other functions which is reported and regulated by this cyclic molecule. Like this molecule can modulate also like stress, acid stress response, protecting DNA integrity, and it is also associated with antibiotic resistance and biofilm and so on. There are several studies about this molecule still going on. So, how this molecule, how the homeostasis of this molecule is maintained in bacteria. This is basically upon any stress, this diadenylate cyclase can decay or desynthesize this cyclic AMP molecule from two molecules of ATP, which in turn bind to different receptor protein or receptor proteins and it will generate output. So when the functions was done, the phosphodiesterase basically break down the cyclic AMP to PAP. And so far there are 5 DCL or DAC homolog was calculated. Those are CDA-A, CDA-A, CDA-M, and CDA-Z. So today we will mainly focus in this group, this overall DC that contain a DAC domain basically and a linker domain and then inhibits domain, which is observed in the case of bacillus, sulfurix and thermocouple. And in microbacterial system, we have a homolog present in microbacterial system also. So when we talk about the structure of this thermocouple molecule, which is coming out from the plate, you can see that this protein is a octameric protein, and in the code they have found the density of the cyclic identity molecules, and it studied a monomer which is consisted into three domains. First is the DAC domain. That domain is called the co-peripheral, the 18 terminal interaction, and there is a linker domain and a domain. So upon medicinal analysis, they have established that this protein actually binds to four molecules of ATP and synthesizes two cyclic diethyl molecules. And one interesting feature that I have discussed, this protein also able to bind the holidays on DNA when bacteria encounter with any DNA balances. At that time, secondary production was inhibited by allosteric inhibition by it binds to the. So there are several structural and functional information reported for this protein or molecules, but in microbacterial system, as I told you, this molecule is generated by two molecules of ATP, and this is basically the DC protein is synthesized cyclic diet. And we have two aspects of cyclic diet signaling in microbacteria. One is regulation of microscopic possibility in different stress, and another one is post-immune response. So the importance of this protein and molecules actually for the attraction of several pharmaceutical companies, but there is no structural or functional information available for this system, for this protein in microbacterial system. So with these key questions, we have explored different functional aspects of microbacterial, different functional aspects of microbacterial disease, and we have also investigated the structure of the disease by RNA. And we have also investigated different domain functionalities, which we will discuss later in the presentation. So, as for the biologist, protein biologist, we have known the protein, and then we did the mass analysis by sigma analysis, which found that this microbacterial disease actually exists as a two-octamer, and this is the mass spec analysis of the protein, which suggested the monomeric mass of the protein. Then we perform the activity assess of the basic protein by HPLC analysis, where we have taken ATP, AMP, and cyclic AMP as a control. Then we have carried out the activity assay. Then you can see that we have carried the activity assay at pH 7. So when we carried out the activity at pH 7, we found out for this are two main things. One is near for 20 minutes and one is near 21 minutes. So this correspond to 21 minutes further investigated and further confirmed by this mass spec analysis to be the cyclic identity. So as you see that at pH 7, the cyclic identity production by this protein was very low. So we have optimized cyclic identity production under two conditions. One is in slightly acidic condition, that is pH 5.4, and another is pH 19. And surprisingly, we have seen that at pH 9, the cyclic diabetic production was optimal by this protein. Here you can see that this protein catalyzes all the ATP molecules to cyclic diabetic molecules, but the production is again very slow at pH 2. So this primary investigation helps us to give and it gives us a clue about the functional regulation, which we will discuss later. So next we have to confirm the product by mass spec analysis. So we have first imputed this structure to HPLC profile, and then subjected for mass spec analysis, and we found the mass of active molecule, which is 657 Dalton, and we confirmed it. That is this peak which is generated after reaction is cyclic AMP. And we have noticed and interesting observations when we characterize these nucleic fractions using mass spec analysis. We have noticed that this nucleic fraction primarily carries two molecules. One is PAK and one is AP. So these two molecules are basically we have characterized, and these two molecules are known as synthetic, actually intermediate during cyclic IMP formation. So after that, we have did the functional biochemistry of the reset protein, and as I talked earlier, that these proteins show optimal activity at pH 7, and also we have performed the functional assays at different salt concentrations. So and we optimize that at 75 millimoles of concentration. This protein show optimal activity. And we have also checked the substrate specificity of the protein by incubating the protein with different substrate like ATP, ATP, AMP, AMP, CPP, and AMP, PCP. These two are basically non-hydrolyzable atoms. So here we can see that the optimal activity of the protein is achieved in the presence of ATP, and we want very less activity in the presence of ATP. So, and we established that ATP as a primary substrate of this protein. Next, we did the enzyme kinetic analysis of this protein in three different pH, and you can see that we have performed the kinetic analysis in three different pH and find out that at all pH, this protein follows substrate inhibition. That means the higher the substrate concentration will reduce the activity of the protein. And this observation actually correlated that, from this observation it correlated that the cellular ATP might have important role, might play an important role for this enzyme kinetic operation. So next an interesting observations we noticed that when you take the mass spec of this protein, as I have shown in my earlier slide, we always keep the mass around 1 kilodalton in the case of normal protein. But surprisingly, we have found that the protein is bounded with the cyclic IMP molecules, and the molecular mass of that cyclic IMP molecules is shown here. So we have just with curiosity we have noted the structure of this molecule by CT spectroscopic analysis. The black color represents the alpha-helical model of the PCB protein. But what is very interesting here, you notice that when we incubated the image specimen with ATP, basically the substrate of this protein, the helicity value increased at 0.08 nanometer. So this actually gives us clue about structural organism of this protein, where the helicity index of the protein increased when we incubated the protein with ATP. And this actually observation was confirmed by KM analysis of the protein with the substrate. Here you can see that we have measured the KM analysis, and the protein length was found around 70 nanometer. But when we incubated the protein with the substrate ATP, the length increased to 90.17 nanometer. So there is around 2 nanometer shift of this protein happens when we incubated the protein with ATP. So based on this observation, we concluded that basically this protein is bounded to this protein bounded to the product cycle AMP, which we noticed. But when we incubated ATP, the ATP, the cyclic AMP molecule comes out from the structure, and during that synthetic of substrate, structural organism happens. And next, we actually visualize the protein by chem analysis. And as here you can see that the protein is homogeneously distributed, and then we have taken the cubic class analysis of this protein. So this protein was showing good result in chem analysis. So we thought to pursue a structural study of this protein, and we collaborated with Dr. Vinod Kumar from NCBS for this structural studies. So these are the different technical parameters of IVM studies. And here actually the processing of the cryogenic was shown here. The image actually shows the cryogenic processing pipeline of microbacterial research, which is started with the microbacterial cooking, then followed by three rounds of cubic classifications where these first particles were taken, and then we have then the cubic classification was followed by initial model generation. And the best model actually from this C1 symmetry was taken for final model generation. After the final model generation, we have generated this model, and the local resolution of this generated model were analyzed or resolution were mapped by reference software. Here you can see that these two cryogenic map actually showed the exterior orientation of the protein, and the right hand side, these two maps show the interior orientation of the protein. And these zero images actually represent the different alpha helices and beta stranded of the backbone. So after all this technical analysis, which actually carried out by Dr. Vinod Kumar's lab, they have generated, and personally we have actually generated this cryogenic map of this protein. Here in this cryogenic map, you can see that each protomer is colored visualize the protein, and this is the side view of the protein, and this is the top view of the protein, and this is the view of the protein. So here you can see that one protomer is interacted with other two protomers. So next what we did, we have generated AlphaFold generated model of the microbacterial G-set protomers. Here you can see that the AlphaFold generated model, and in this, and the next what we did, we use all the protomers and plots in the corresponding density of cryogenic map, and a final model was generated by input all the density in the model. So after the atomic model generation, we notice that basically there in the N-terminal interaction, this N-terminal interaction is mainly consisted with 6 protomers instead of 8 protomers, which we notice in the case of thermochroma DC. This interaction does not invert two protomers, which actually leave open and give rise to open structure in this model, and which basically disrupt the protein symmetry. And the symmetry we got here in this slide. If you see the earlier published thermochroma structure, you can see that this structure follows the symmetric model where there is no disruption of this C-terminal domain, and the chain interaction is like this with all the monomers. But when we generated our model, then you can see I have mentioned all the chains in different color. Here you can see that the chain A and the chain B interaction is like the thermochroma protein. And but when you see that interaction between chain C and chain C are according to the distance like 31 angstrom, and also chain F and chain E, which is distance like 28 angstrom. So this here in this image I am trying to show you the differences between the structure of this protein. And next, if you see the structural comparison in the N-terminal domain, the catalytic core basically in the practical DC, it is like quite a open structure compared to the thermocouple molecular DC. So, and here actually we superimpose in the internal domain of this thermocouple molecular DC and antibacterial DC. And these are the different important residues shown here. So the structure of these two proteins are different. Next, we have also noticed an additional density within the putative nucleotide binding domain in domain 346 million, which is surrounded by the NHBT2023 domain interaction. So this actually creates the dynamic interface in dynamic interface of the DC, and the density of the ligand is shown in different terms. So from this analysis, you will notice that cyclic molecule is very nucleotide which is shown here. But we have not modeled the cyclic INT. So what we did next, we characterize this nucleotide binding by biochemical analysis. But we have dropped the specific protein into the nucleotide, and here you can notice that one residue, that is BT84, is shown interacting with this nucleotide, and another residue which is histidine 137, that is also interacting with the nucleotide. So based on this model, we have generated this protein and manipulated the astatic acid residues to alanine and also the histidine residues to alanine. And we found that both of the typical for nucleotide binding and the activity of the protein. So after this, we just go back to the binding of this DC protein. We have generated the asymmetric structure of the protein, and the earlier structure was symmetric. If you remember the earlier model, you can see that this protein interacted with the DNA of this model. So what we did, multiple sequence arrangements, we noticed that the residues at the DNA binding conserved in this class of bacteria, like Muscariasis and Tuberculosis, Bacillus and this residues remain conserved. And this residues are conserved. So we go ahead and read the DNA binding assays with DNA with NHBT2023. This is a for this experiment we have taken one control that is Bacillus subtilis assay. There you can see that you can see a clear formation of the DNA protein complex in the Bacillus subtilis assay. But when we integrated the DNA with antibacterial assay, you can see that in both pH at pH 7.9 or pH 9.4, there is no binding. This protein does not bind to any type of DNA. And later actually we characterize the activity of this mechanical DNA in the presence of different type of DNA. We have used we have used thermal DNA and also the double-stranded DNA. In each cases, we have noticed the formation of cyclic diachromate. So the theory of DNA binding and activity inhibition by DC, which we noticed in the case of abnormal and this antibacterial DC. Next, what we did, we have actually characterized different domains of the protein, and we have created protein mutant of this protein. And as you can see, we have taken the internal domain and the internal protein and the microarray. And we have characterized by second analysis, and we notice that the internal model with the connecting helix, that is internal domain, and the connecting helix actually can form orthogonal, and it will also show the activity. And only the internal domain, like the residues 1 to 158, they can also form the optomeric model, and they can also they can also able to convert ATP to cyclic diamine. But the C-terminal domain, as expected, is unable to catalyze ATP molecule to cyclic diamine. So on this study, we have confirmed that the internal domain alone can catalyze ATP to cyclic diamine molecule. And next, actually, with this, I will summarize this work. And so far, we have functionally studied the PC protein by in different pH, salt, and substrate concentration. And we have also checked that substrate induced activity inhibition, which is reflected by our kinetic model. And another is this protein actually does not bind, and export the DNA binding property also there. And in structural aspect, we notice that substrate induced structural changes by this protein. And we have just generated a 3.1 trivial map of this protein. And we also showed that the manufactured DC follows asymmetric structure. And by our medicinal analysis, we have found different important residues of this protein. And we confirm that internal domain binds to the nucleotide, and the internal domain can only functions to catalyze the cyclotide synthesis. So this work is currently published in Publications. You can further and read from this paper if you are interested to study. And next, actually, what we are currently doing here at PPIL. So I have discussed two different aspects. One is microbacterial phenotypes, one is stress responses. So there is also two different aspects of cytokine inhibition regulation. One, you can target the synthetase assay, or also you can target the hydrolase. By inhibiting the cytokine synthetase, you can inhibit the bacterial phenotypes, or by inhibiting the cytokine hydrolase, you can inhibit the host-pathogen interaction, which is in turn beneficial for us. So in this structure we have now generated, and earlier there was structure of D. So now we have the structure of multifactorial D set and multifactorial D both. And based on the structure of the cyclic diamine, so we have created a molecule library, virtual library of 80 compounds with what is with Dr. Devras Mukherjee, who was initially a scientist here, and next he moved to this. And we created a library of 50 compounds, and then we brought the compounds with manufacturing DC and NP. And surprisingly, we found that some of the compounds could approach to contact to the ligand itself. And we are now actually synthesizing this molecule without the. So with this I will actually end my talk, and I want to thank you for CSR Shani and Dr. Ratli Soni IISc, and CSR for my research support. It's Dr. Chatterjee, under my previous doctoral work, and Dr. Kiyasani and Professor Subrata Sir, Chairman is my PhD and PhD guide, and Professor Subrata Sir narrated my PhD test. Dr. Reddy sir, who is the present director of our institute, and Dr. Kumar Putri, who is for the primary structure and all the technical, who take care of all the technical things regarding this learning. And Dr. Biotechnology in has started the work there. I'm not totally sure, so it will share out experience in this work. And this is my group here. Yes, thank you.
Thank you, sir, for an insightful talk on this topic. I will now request the audience to present any questions they have. Any questions? I think there are no questions. Thank you, sir, for taking out time from your busy schedule for this session. And now we come to the end of the technical talks. We will now be proceeding with the poster presentation. Okay. Now we will be continuing with the poster presentation session. The time limit for the poster presentation is 5 minutes, and there will be a warning bell at the 4-minute mark.
We will be having Dr. Rabindranath Jana sir, Associate Professor, Department of Chemical Engineering, HIT Haldia, as our judge. As mentioned earlier, the time limit will be 5 minutes for every presentation. The team to be presenting now is Anushka Rai Chaudhary, Mr. Ranjay Kumar Thakur, Dr. Shubhika Das Biswas, and the topic for the presentation is Biotechnology for Green Future of Wastewater. Participant, please come on stage. Good evening to the respected judges and my fellow batchmates. I am Anushka Roy Chaudhary from the Department of Food Technology, and I am going to be presenting a poster on the topic of biotechnology for green future of wastewater. So the main objective of today's presentation is the global water crisis and the sustainable solutions what biotechnology gives in wastewater treatment. So, how many of you are aware of this fact that in the countries like Africa, people are dying due to trust, and on the other hand, in the countries like India, we produce more than 72 billions of wastewater per day, and that directly affects the economy and as well as our environment. So, what can be the solution of this? The wastewater treatment plant can be the sustainable solution for these processes. And the biotechnological processes in these fields takes the main lead by implementing those microorganisms in those processes. So what actually wastewater consists? Wastewater, as we can see, wastewater mainly consists of all the nutrients like nitrates and phosphates, and also large heavy particles and large metal particles, some pathogens and toxic chemicals in it. So as we are running out of time, so I will not go in details to the processing. So the processing mainly is classified into four parts: preliminary, primary, which are basically used in separating the suspended large particles from the water, and the main important part, which is the secondary treatment plant, or the biological treatment plant, which actually have the aerobic bacteria in the aeration tanks where the continuous oxygen supply is present, and the bacteria coagulates with the organic wastes and settles down, and thus it is removed. And after that, the tertiary treatment processes leads the chlorination, bromination, etc. to kill those microorganisms. Now this water is completely reusable. But there is a problem behind this. This process is very much energy consuming, as well as very much it needs a high installation cost due to those big instruments as well. So we have come up with a solution with anaerobic treatment bacteria. So here we use anaerobic bacteria instead of aerobic bacteria, where the anaerobic bacteria treats those complex biopolymers into the simpler form, and the final product we get is methane and carbon dioxide, which we know that the great source of energy. So by producing the energy, we can quench the thirst of energy in this process, and thus the anaerobic bacterial treatment is more efficient, more cost effective and energy efficient as compared to the aerobic one. So here there we can see a lot of implementations have happened, and as the byproducts of this we get the biofuels as well as the biomass, which we can use as to produce fertilizers as well. And the statistical analysis shows that the implementation of biotechnological processes in wastewater treatment is raising higher day by day. And the future aspect says that India can produce this global market up to 2 billion in 2025. So let me conclude the topic of discussion. Let me conclude the topic of discussion. As we know that wastewater treatment is very efficient for our environment, and by using biotechnological processes, it makes the carbon footprints lesser, and we can implement in our daily lives as well. So if we get the proper maintenance and the funding, it will help making the environment better. Thank you so much, and I would like to thank my respected teachers, Sir Ranjay sir and Sumita ma'am, for helping me out in this project. Thank you so much. Do we have any question from the audience?
Hello. One question from my side. Actually, for say the aquatic animal, how much visual oxygen is required? Minimum visual oxygen required for an aquatic animal to sustain. Okay. Another question, say in a plant there is a continuous generation of wastewater, but sometimes with that water, that nutrients, whatever we are talking about, that constant amount of nutrients may not be present. So the bacteria or microorganisms, whatever is present in the wastewater treatment, that they may not live actually. So what is the alternative to live that microorganism, to sustain that microorganism?
Yes, sir, that's right. That basically depends on the origin of this wastewater, from where it is coming on. It can be from industrial sites as well as the domestic wastewater. So there are a lot of nutrients present, but if there is a lack of the nutrients, so we can add we can add those microorganisms from the outside sources, aerobic and anaerobic bacteria.
No, not microorganisms. I am asking about the nutrients for the microorganisms. What should we add the nutrients or from outside?
So basically, microorganisms use those nutrients which already are present in the wastewater to metabolize and their metabolism as well.
Yes, sometimes if there is no nutrient present, then what will happen?
Yeah, then for continuation of this process, we can add also nutrients from outside as well. Thank you, sir. Thank you, sir. Next, we have Shamawa Khurshi, Mr. Ranjay Thakur, Dr. Shumita Das Biswas, and the title of presentation is Biofortification using Nanotechnology.
So, good evening to everyone present here. I am Shimama Khurshi from Biotechnology Department, second year, and today I am presenting a poster on biofortification using nanotechnology. So, biofortification is a process by which edible plants are enriched with essential nutrients for human health against malnutrition. Biofortification increases micronutrient content in staple food crops and can be achieved by a number of different strategies like agronomic biofortification, conventional proceeding, and genetic engineering. So, agronomic biofortification involves fertilization of food crops with micronutrients through physical application, either directly to the soil by foliar spray or by seed priming or immersing the seedlings in the fertilizer solutions. Genetic engineering is a new technology, advanced technology, where now the nanotechnology has the potential to revolutionize the agriculture by effective delivery of agrochemicals and may be used for the biofortification of food. crops. In nano-biofortification, the crops are enriched using essential nutrients using nanoparticles. This This biofortification through nanotechnology-based approaches, here we have top-down approaches for physical method and bottom-up approaches for chemical methods, and biological method includes both physical top-down approaches and bottom-up approaches. This is a biofortification process for different zinc, iron, selenium. Now, this shows how the nanoparticles are uptaken by the roots and shoots of the plants. And this table shows the different crops like wheat. If we add the concentration of 50 to 5,000 milligram per liter and the nanoparticle type is zinc oxide, then the enrichment will be, zinc enrichment will be good. Now, this technology has potential benefits. It increases the light absorption and the roots and shoot growth and soil enrichment. Future technology of nanotechnology applications are crop improvement, plant growth and feed, and storage and transport. At last, I would like to conclude by saying that nanotechnology, biofortification using nanotechnology is done best because it releases at a controlled rate. Thank you.
Any questions from our audience? Yes, one question from my side. Mention one instrument by which we can measure the size of nanometer.
Size of nanometer.
By which instrument we can measure the size? There are so
I don't know the exact name.
Oh.
Thank you, sir. Next up, we have Kaushiki Mojumdar, Shuparna Das, Mr. Shaurya Anand, Mr. Ranveer Thakur, and the title of presentation is Biocomposite Material and Insight.
Good evening, everyone. I am Kaushiki Mojumdar from Food Technology Department, second year. Today, we are going to present a poster on biocomposite materials. So, what are biocomposite materials? These are substances which are composed of biodegradable polymer matrix and natural fibers. Their affordability and recyclability make them a sustainable alternative to the traditionally used petroleum-based plastics. Now, let's move on to the various properties exhibited by these materials. First, we have chemical properties. The natural biofiber-based biocomposites exhibit certain desirable characteristics which include renewability, biodegradability, sustainability, environmental friendliness, energy efficiency, etc. The mechanical properties, on the other hand, are based on certain crucial factors which include the compatibility of fiber and matrix and their properties related to them. Now moving on to the methodologies used for the production of biocomposites. So first we have injection molding technique. The injection molding technique is well known for the production of intricate designs and with accuracy and consistency. So as we can see here, here we have in this end we are feeding the machine with plastic granulate, and here the screw is present which helps to transfer the molten plastic passing through the heating chambers to move towards the mold which is connected to a cold water supply. When the molten plastic reaches the mold or the cold section, it takes up a desired shape and solidifies, and hence we obtain the biocomposite material. Next up we have hand layup technique. The hand layup technique is one of the oldest and straightforward techniques to obtain biocomposite materials. So here we have mold which is treated with releasing agents, and then the layers of resin or biodegradable polymer matrix is put layer wise, and a uniform layers are formed using a roller. The last process we have compression molding. Compression molding consists of two mold halves. The upper mold is the movable one, while the other one is fixed. The upper mold provides pressure to the charge or the material, source material, and we obtain the desired shape of the biocomposite materials. Moving on to the applications. The biocomposite materials exhibit a wide-scale application in automobile industry, packaging, sports, construction purposes, etc. Through this poster, we have tried to showcase various mechanical, chemical properties and advantages of biocomposite materials. The advantages include biodegradability, sustainability, environmental friendliness, renewability, recyclability, etc. The main issue lies with the moisture absorption and low adhesion power, which can be treated by fortification or addition of synthetic or artificial substances to the natural fibers. That's it from our end. Thank you.
Thank you for the presentation. Are there any questions from the audience? Sir, do you have any questions?
So to enhance the biocompatibility, biodegradation, is there any chemical generally are added to plastics?
So we can add polylactic acid for this purpose, which is a natural polymer, biopolymer, which increases the strength of the plastics.
Yes. Okay.
Thank you.
The next presentation is by Devankana Bose, Nisha Nath, Shalini Chaudhary, Shrishtilata Jana, and Mrs. Ahana Bhatti. The topic is the role of mushrooms in bioremediation. Please come up on stage. And they are from the Department of Biotechnology of Haldia Institute of Technology.
Good afternoon, esteemed guests, professors, and everyone present here. And we are going to present a poster titled The Role of Mushrooms in Bioremediation. Let me start by stating the versatile ways in which mushrooms have helped the human community. It has been used as food, medicine, in the textile industry, as packaging material, as well as biofuels. Mushrooms have also helped to protect and clean the ecosystem by the help of bioremediation. Bioremediation is the process by which microorganisms eliminate waste and pollutants from natural resources such as soil and water bodies. Here we have shown a table that shows various mushrooms such as Phloratus austratus, which helps in the removal of green polyethylene, polycyclic aromatic hydrocarbons, as well as heavy metals. These mushrooms also help in the removal of crude oil, dyes, etc. Mushrooms have an add-on benefit. They release certain byproducts such as enzymes, medicines, and food materials which can make the bioremediation process even more profitable. Here we have shown a diagram showing the SMC or we have shown a diagram showing SMC or the spent mushroom substrate. Spent mushroom substrate are the residues which are formed as a result of mushroom production. Spent mushroom substrates help in the process of bioremediation by biosorption, biodegradation, and biotransformation. These are the different methods by which microremediation helps in the purification of the environment. Biodegradation is the process by which various enzymes are released and they degrade the toxic substances into non-toxic components. One example of this process is the white rock mushroom. It releases the enzyme phenol oxidase, which breaks down lignin compounds. Biosorption is the process by which mycelium of the mushroom takes up the heavy metals such as cadmium, lead, and iron from the soil and purifies them or stores them in their own body and makes the soil harmless. Bioconversion is the process by which the waste land or wastewater is rendered harmless by the transformation into useful products. We have the mushroom trematus, which releases the enzyme lactase. Now, lactase is an oxidoreductive enzyme. It converts the lignin components into non-harmful components, but it also has a property of biosorption by which it takes up the harmful metal cadmium and stores it in the mycelium, thus making the soil less harmful. Thus, we have come to the conclusion that mushrooms can be very efficient and cost-effective in the process of bioremediation and to make the ecosystem cleaner and purer. Thank you.
Thank you very much for a wonderful presentation. Any questions from the audience?
That by bioremediation, toxic chemical or even toxic metal from the soil, for example, it is being absorbed by the mushroom. So that mushroom can we consume?
Sir, the mushrooms have a very huge biomass and they have a very high growth rate. So even after absorption of those harmful heavy metals or toxic pollutants, they can still be consumable, certain mushrooms, but certain others have also proved to be unconsumable. So it depends on the species of the mushroom that we are talking about.
Okay.
Thank you.
The next presentation is from Ritoshri Bandyopadhyay and Dr. Shambhu Chatterjee sir, from the third year of the Department of Biotechnology of the Institute of Technology. The topic for the presentation is Evolution Through a Looking Glass, the Micro and Macro Vantage Point.
Good evening, everyone. I'm Ritoshri Bandyopadhyay from the Department of Biotechnology, and I'm presenting a poster titled Evolution Through a Looking Glass, the Macro and Macro Vantage Point. Now, evolution is a term all of us have heard, even read about, but probably we haven't thought it through that evolution can be viewed from two different aspects. The micro aspect is the genomic way of explaining evolution, and it's done mostly by studying the evolution of a specific kind of gene called Hox genes. Hox genes, as you can see, they are not just of two types, there are more types, and they are very conserved in nature because they control several metabolic and anatomic factors in organisms starting from the mid-Arians and above. And they are present in multiple clusters, especially in vertebrates. Invertebrates have just a single cluster of Hox genes. Now, these genes are so crucial that their mutation can lead to severe anatomical changes. And if we follow this diagram, of the Drosophila, we can see that the Hox mutation has led to the development of legs instead of the antenna. So that's how incredibly crucial these genes are. But then the question arises that why are we studying these Hox genes? Because okay, it's just a mutation, it's just a body deformity. But no, there is competition everywhere in the college campus as well as in the environment that we live, and from this competition aspect, any body deformity puts the organism at a very vulnerable point. This antenna, the absence of the antenna or the growth of the legs instead of the antenna puts this Drosophila at a very vulnerable point. And just imagine a similar thing happening to human beings or us, developing a mutation which leads to the absence of our thumbs or maybe the entire hand. So from the competition aspect, these Hox gene mutations are very crucial. That's one side down, the micro side down. And the macro, it states that evolution is simply a result of environmental changes. It studies evolution for a long time span, like 10 to the power 5, 10 to the power 6 years at a time. And it's mainly controlled by and the changes are with respect to that of climate, environment, sunlight exposure, humidity, salinity, and resource availability. Microevolution states that if you follow the graph, according to microevolution, the species change is gradual and there is no branching in the phylogenetic tree, whereas macroevolution, it's the entirely opposite. Changes are drastic and there is formation of different branches in the phylogenetic tree, as we can see in this diagram. Anagenesis is simply a result of microevolution, whereas cladogenesis, that is splitting, is a result of macroevolution. Now, these are the two hands of evolution very well. They happen at the same time in nature, but we haven't yet found out that at which point it's no more microevolution, but just the macroevolutionary effects that is leading to speciation or changes in general. There is one way or one attempt to explain it using something called an adaptive landscape. This adaptive landscape is a multi-dimensional space with species fitness going up and genetic changes and environmental factors. So you can follow the graph. There are peaks, there are valleys, and then there are negative peaks, which have their own significances. Peaks shows species is showing incredibly high adaptability to that genetic configuration and environmental factors. A negative peak means extinction. Now these valley space organisms, they're very crucial. They show moderate adaptability, but they are at a they are at a lesser chance of going extinct in case of any change in either of the factors that we have mentioned here, genomic or environmental. So if it is that easy to study valley line organisms, then why haven't we found out the exact point yet? Because the organisms that lie in the valley space are planktons and they do not leave behind a fossil because of the lack of their exoskeleton. So the gap still remains. Thank you.
Thank you for the nice presentation. Any questions from the audience?
অনেক টাইম হয়ে গেছে
Hello. So, according to you, and through your study of housing, what's your prediction for the next evolution of human? What will happen with us?
Yeah, that is, because of the time limit, I couldn't mention a few very key factors. Genetic changes are completely random. You cannot map them. Even if a change in my gene forms a unique novel gene which is found in some other species, I don't know what the epigenetic changes will do to the functional protein that will be formed after translation. So it's completely random at the micro level, whereas it's totally directional at the macro level. We know what the changes are. We can predict them. Like, because if it is studying evolution at a range of 10 to the power 5, 10 to the power 6 years, geologists, they have known that these are the tectonic movements. This is when a solar minima happens, leading to which there is an ice age. So these changes are mapped from previously. But that's not the case with the microevolutionary changes or the Darwinistic changes, Hoxton mutations. Which is why it's again, we need the adaptive valley level organisms to study it, and we do not have their fossils.
Thank you for the question, sir.
Yes. So the last figure, I do not understand, that is the adaptive lens you are talking about. So from which instrument you have taken that picture?
Sorry sir, can you please repeat
That
the question?
instrument, or it is just computer programming?
No, sir, it is actually a combination of statistical data based on species survival against varying genetic changes and the environmental changes.
So computer,
it's a computer generated image based on the data input that's given. Thank you.
Thank you for the presentation. The final presentation for the day will be done by Shoraditya Chaudhary and Dr. Kiya Shah from the 4th year of the Department of Biotechnology. The topic for the presentation is codon U, a Python package for codon users analysis. Good evening, everyone. I hope you all are in just a fine shape. Today I am going to discuss about my own written Python package. The name is Codon U, and that's just the abbreviation for Codon usage analysis. Now, apart from the jargons, coming to the codon usage, you see there are 64 codons in our body. You all know that, right? But the amino acid number is only 20. That means various amino acids are being encoded from more than one type of codons. Now the subset of codons which encode to a specific type of amino acid is known as synonymous codons. And in case of various species, the studies indicate that a special codon from the reference set of synonymous codons are being preferred, and those are known as optimal codons. Now, coming to the introduction part. Codon usage analysis is not a new term in the field of bioinformatics. It has been here for a many long time. But with the advancements in computer science, the field has been greatly debated over. Like, what if we do the analysis with a computer programming language? You see, there are more than one gene and there are more than one genome. In case of, as you can see here, in case of human chromosome 2 only, the number of genes is 9,402, which is pretty a large number to analyze. So our approach is to analyze the codon usage with the help of a computer language, and for that, in the late 1990s, codon W was first introduced language, which was a grand success then. But the problem with it was that it is a command prompt based tool, or rather known as CMD rule. And also you personally had to download the GeneBank format of the file from NCBI database or your own database. Then you had to extract the coding regions or coding sequences, formerly known as CDS in this subject. Then you have to manually feed them to the Codon W program. And with the help of Codon W program, you can calculate relative synonymous codon usage or RSCU, codon adaptive index or CAI, codon bias index or CBI, frequency of optimal codons or FOP. But the thing is, it was better in 1990s and now we are living in 2023. C programming language is not that kind of popular now, and also the export format has been vigorously repeated over. Like for that time, the export was in .txt extension. But now, as you are new generations, you must know the names or at least the topics of machine learning or artificial intelligence. And if any one of you are accustomed or familiar with that, that you know we need .csv file or Excel files. And for this pipeline, if we use that .txt, it is going to crash the program. So let me take you to a tale of the proposal of Codon U, like why we did it. First, it is written in the Python programming language, and as a matter of fact, many of you have already heard the term Python programming language. And second of all, in the case of Codon W, you may remember I told a minute earlier that you had to manually feed the data. But in this case, you just have to feed the accession ID and it will fetch the coding sequences directly from web, thus saving the space in your local computer. And in the case of the analysis, with the help of new hardwares or the GPUs and CPUs, we have a greater province for the calculation part. Now coming to the updates we have. You can see here some cards like this one, this one, this one, and this one. This one is the correspondence analysis card in the codon frequency, and the scale is length of gene. In case of codon W, it was impossible to make it from codon W itself. You need the data, you had to feed it to an Excel sheet or SSPS or any other software, and then you may plot these kinds of math. But with the help of codon U, you can directly plot it. Like this was from codon frequency, and this is from codon relative synonymous codon usage values. In case of proteins also, and as you can see here, you can see two complete different trends here, and this was not achieved by codon W. Or these curves, like here, the ENC curve. The ENC is nothing but effective number of codons. Now you can see that this is for Staphylococcus agnatis. And from the last lecture, we have seen the evolution from the microprospect and the macroprospect. Here you can see a complete cluster, but in comparison where we can see in the human chromosome 2, there's a complete cluster below the curve. And in this case, it just cuts the curve across. This actually means, or the implementation or implication of the result is, there's more mutational bias in this case rather than this case. Or like these two curves that you can generate with the help of codon U. Now this is the peer-to plot or parity rule to plot. I hope you can guess it from the Chargaff rules. And these are the neutrality plot. So basically here we are proposing a novel Python package with which you can calculate with a very small time and also can generate these kinds of beautiful plots. And in a bit technical note, these plots are each 500 dpi and the optimal publishing resolution is known to be 300 dpi. So you can publish this kind of image both in net or in papers or otherwise. Now coming to the conclusion. With emerging technologies and advancement in computer language, it has been possible to enhance older systems and make them more user-friendly. The package is the updated version or the vision which was first proposed in codon W. But in case of codon U, we are just providing the users a much more simplified interface and higher availability and functionality. And these code as of now is deployed in GitHub, and you can find it here as the link is given, and these are the references. And here I would like to conclude my talk, and I am acknowledged to my PI, KR ma'am, and our HOD ma'am. So that's it. Any questions?
Thank you so much, Doctor. Any questions, sir? Any question from the audience?
Okay, in that computer simulation, the deviation, mean deviation, I think it should be mentioned. And that programming, what programming we have?
So here we are using Python programming language, and as you said, the deviation. In case of here, you can see the R-square value for the neutrality plot of Staphylococcus. Now, neutrality plot is nothing but the correlation plot of the probability of G or C being present in first or second codon to G or C being placed in the third codon. And you can see with our calculations, the R-square value is really less, which means the deviation is really less. And that speaks, the value speaks for the question itself.
Okay,
thank you, sir.
With that, we come to the end of the poster presentation session and the technical session for today. Now, this is an important announcement for the first year students. Tomorrow morning, we will be starting with the first year poster presentation. So all the students are requested to report to SM Bose Auditorium by 9 a.m. sharp. And on behalf of everyone, I would like to thank Dr. Jana sir for judging the poster presentation.
কি বললো?